How are you doing? Ooh, cool. Awesome. We have one more day of exciting talks, and I'll do some housekeeping, some announcements. So first of all, I would like to thank our sponsors. Without them, this wouldn't be possible. We are very, very grateful for the generous support. Second, if you can, you should donate to the UCSC Strike Fund. Maggie has put up a sign outside where she'll be matching donations up to $500, and there are details of how you can help contribute. The other thing is we have a code of conduct. You can read it on our website, and if you can either send us an SMS on a number that will be displayed here during the breaks, or you can flag one of us in a yellow T-shirt and talk to us. And there's a Google form online where you can send in anonymous complaints if you have them. The other thing is that we have a quiet room. The quiet room is across the courtyard. And if you can't find it or don't know where it is, you can again flag one of us in yellow T-shirts, and we'll show you the way. The other thing is bathrooms. We have two right outside the auditorium. They're all gender restrooms, and we have men's and women's restrooms. One on the left building, and one across the courtyard again. And if you can't find them, we can again help you. And I want to invite Maggie to talk about Exclamation Foundation for a few minutes. Maggie.
Thank you. Okay, everybody take up your thingy. You don't have to take it off. I'm just taking it off because it was in my way. Turn it over so your name is not facing you. So you may see, and you probably saw this already, it says that BayMainCon West 2020 was brought to you by Exclamation Foundation. So what is the Exclamation Foundation? This past year, we finally incorporated a holding body. BayMainCon and BayMainCon West for a while were run out of one of the original organizers, LLC, which was named BayMainCorn. If you've seen that name around, perhaps you're a sponsor and have seen an invoice from BayMainCorn and been like, I wonder what that is. So now we have an actual holding body. If you're interested in the details, I'll share one sentence of it with you. We are a non-tax exempt nonprofit. So what that means is that we have a board. Lindsay is our president. I am currently treasurer. Julia, who I think is somewhere, is secretary. And we have bylaws that we abide by, and there's no equity or ownership structure. So we're not a 501c3. We have thoughts about maybe doing that in the future so that we can apply for grants and accept personal donations that are tax exempt for individuals. So those are the details. If you are curious about more, and if you're curious about like what we're going to do with this and like what it means for the future of BayMainCon and BayMainCon West, we're curious too, and we're figuring it out. If you have ideas that you want to share, I'm happy to hear them. Lindsay's happy to hear them. I'm sure Julia's happy to hear them as well, and come find us and talk to us at one of the breaks.
Hey, Maggie, how do you email the board of the Exclamation Foundation?
Oh, Lindsay just asked, how do you email the board of the Exclamation Foundation? I believe you can email us at board@exclamation.foundation, and we will get that email. If you go to the website, exclamation.foundation, you will also see a mailing address, which will also come to our email, because it's 2020. That's Thank you.
Thank you, Maggie. Okay, so I want to introduce our first speaker for today. Erin is a digital scholarship librarian, where her work focuses on digital tools and practices to make education and knowledge production more democratic, collaborative, and publicly engaging. And she is going to be giving our keynote today. So please join me in welcoming Erin for our first keynote today.
Thank you. Thank you, everyone. Let me get set up here. Higher. Can you all hear me? Is that good? A little more? Okay. Keep the feedback coming. Let's see.
We're not getting output from this machine.
Should I be? Oh, oops, haha. User error. There we go. Yay. Hi, everyone. My name's Erin, as you know, and I'm really excited to be here with you all. In fact, you're all so smart, so funny, so creative. It's kind of hard to follow you this morning, so bear with me. But thank you so much to the conference organizers, to the other speakers, to the sponsors for putting on this terrific conference. So I've been working at the intersection of higher education and technology for about 10 years, most recently in libraries. And I can't tell you how excited I was to learn of this conference that's devoted to the joy and surprise and excitement of computing. Because I think that's a vision that we desperately need more of, right? It's a vision that's being threatened by a very different kind of use of computers, right? The use of computers to control and exploit human beings. And unfortunately, we're seeing a lot more of that, right? Every day in our personal lives, in our workplace, in institutions of higher education, and also more recently on this very campus. And so I wanted to just start this talk by expressing solidarity with the graduate student workers at the University of California, Santa Cruz, and across the UC system and across the country, right, who are fighting against unjust labor practices and for their right to a living wage. As we heard from Saham Banerjee yesterday, right, more than 50 graduate students were fired, and that's putting their right to be in the US at risk, or many of those folks, and jeopardizing their education as well. But I think we should really thank these graduate students because their action reminds us of the type of agency that we have when we work collectively. And I'm mentioning that because, we're on the campus of UC Santa Cruz, but I'm also mentioning that because it happens to be the theme of my talk. So today I want to talk about three things: technology, education, and agency. And by agency, I mean our ability to critically understand the world around us and to shape it according to our own interests, right? Not according to the interests of the status quo, of the powers that be. And what I want us to think about really is, what does liberation look like in an increasingly programmed world, in a world in where more and more of our activities are being monitored and influenced by computational technologies, right? Or if liberation was a Python function, as I've imagined it in my title, which of course it is not, how would we define it, and how would we teach it? And just to be clear, let me start off. I am not a programmer. I'm a bit of an outsider at this conference. I'm not a developer. I don't work in the industry. I'm really coming to you as a messenger from higher education, a messenger from academic libraries, to really tell you that we need your joyful approach of computing in higher education. Or to say it in sort of the soap opera language of this conference, I had no idea that soap operas were a programming language, but this is what you speak, right? So anyway, I'm here. I'm asking you, look, y'all are really smart, and we need your help because things are getting pretty scary. And you might ask, like, well, how scary? What do you mean? And I'm like, have you ever seen The Never-Ending Story? Like, we're talking like the nothing type level of scary. And you're saying, aren't we supposed to be talking about joy at this conference? And don't worry, we'll get to that. But real quickly about me. I'm a digital scholarship librarian at UCSD. Everyone always asks me, what does that even mean? I'm really helping educators, students, researchers think about applying emerging technologies in their research and teaching. I have a PhD in the humanities, okay? I'm not trained as a computational person. This all happened by accident. I could tell you about that later. And I'm really invested in open source technology and community-driven software, and I think a lot about ethics and surveillance and control. And I'm also a nice person, I think. I try. Okay, let's get back to the strike. I think it's always great to root our conversations and what's happening right now. So as some of you may know, as Joshua certainly knew, there's been concerns in the last few weeks about how educational technology is being used to disempower workers, right? Are administrators using, Canvas, the learning management system, to spy on students, to sort of control behavior, to maybe get in touch with undergrads, to get them to snitch on their TAs? And someone
There's a time when the operation of the machine becomes so odious, makes you so sick at heart that you can't take part. You can't even passively take part. And you've got to put your bodies upon the gears and upon the wheels, upon the levers, upon all the apparatus, and you've got to make it stop. And you've got to indicate to the people who run it, to the people who own it, that unless you're free, the machine will be prevented from working at all.
me, just ask this guy, right? In an oral history in 1995, he said, one of the things that built Apple to computers was schools buying them, right? And what does he mean by that, right? Steve Jobs was really frustrated at the sort of slow pace that people were picking up personal computing. So he ended up developing all these contracts with universities and schools to get them to buy Apple II computers, right? Thus financing, the company, but also training a generation of students to really value Apple II's vision of computing. Okay, and so what this anecdote highlights, whether you love Apple computers or not, is not really the point. But the types of technologies that we expose students to is really going to train them and train their sort of technological imagination about what's possible, what's normal, and so forth. And so I think we all know, right, there's some really exciting possibilities, right? We've seen plenty of talks yesterday. We're going to see more today about the sort of exciting future that we might have, the exciting, digital future. But we also know that there's some really kind of scary and dystopic things happening. And I thought, just so we're all on the same page, let's go through them real quickly. We're going to do it quickly because this is a conference about joy, not about dystopia. But in order to get to joy, we have to face dystopia, right? So one of the major concerns right now is surveillance, right? You all know this. Let's go quickly through what people are talking about, right? Edward Snowden a few years ago revealed that the NSA, in partnership with several technology companies, created this massive global surveillance infrastructure. People were understandably really upset about that. What's happened since? Well, now we just also have surveillance sort of ubiquitously embedded in all of our devices and tools that we use, like the phone, of course, like your television, like your vacuum cleaner, your Airbnb, your personal assistant, your social media, your search engine, your grocery store, right? And then we even have more tools that are specifically, for neighbors to spy on other people, your dating apps, et cetera, et cetera. Okay, we all know that. And another thing we're seeing, right? It's not just about people aren't just concerned about the surveillance in itself. It's what this is enabling companies to do through their tools. So, we all know about the Facebook mood manipulation experiment, which might be valuable, right? If we can manipulate moods, turns out certain moods make people more susceptible to advertising. So that's interesting. We know that companies can delete things off of your machine. They can slow down your device's batteries. They can devise things in hopes of making them more addictive. And then they can, possibly even manipulate public discourse. This is debatable, but right, we're seeing that actually our communication platforms really have quite an effect on the way information is sort of passed on and how that shapes public understanding of current events. Do you remember this? Last fall, Elizabeth Warren was sort of calling out Facebook's policy to allow candidates or politicians to make false ads on Facebook. So she said, okay, you really want to do that? I'm going to create an ad that claims that Zuckerberg endorsed Trump's reelection. And so people right now are pointing to China, right? Like, wow, this is really scary. Look, China's using facial recognition and other computational tools to, basically monitor and influence the behavior of its citizens. Isn't that scary? And, hey, actually, maybe we're also doing something similar here. Okay. But what's the problem? So I'm glad you're laughing. That's reassuring. But we have to talk about it. What do we think about this? Well, there's been just an absolute explosion of literature from journalists, from scholars, from concerned citizens about some of the problems that stem from these forms of surveillance and control. I'll just go over a few of them. Right? Are any of you familiar with this book? Yeah, it's a great book, right? Sophia Noble wrote this book called Algorithms of Oppression, and she says, look, search engines can reinforce racism if we don't have, the right people sort of helping build these systems. Virginia Eubanks wrote a book called Automating Inequality, How High-Tech Tools Profile, Police, and Punish the Poor, right? Again, another example of how these technologies are exacerbating existing forms of social inequity and injustice. Human rights organizations have said, these surveillance giants are really threatening human rights. Here's another book that made a big splash in 2019, controversial, but just to quickly sum up its thesis, Shoshana Zuboff sort of describes this thing she calls surveillance capitalism. And she says this is like a new economic logic that aims to predict and modify human behavior as a means to produce revenue, market, and control. And really what she's saying is all those forms of surveillance and control that we just looked at, those aren't bugs, right? We hear this all the time. It's not a bug, it's a feature, right? That this is the logic, right? Driving a lot of our technology today. And she says what this is causing is the rise of instrumentarian power, right? The power to sort of manipulate behaviors of populations at scale. And she, interviews a bunch of people that say, yeah, quite frankly, that's what we're doing. The goal of everything we do is to change people's actual behavior at scale. And okay, what's wrong with instrumentarian power? Well, it threatens individual autonomy and democratic processes. But, I don't know if you relate to this. What do you do? I mean, have we really changed our behaviors? Have we given up tools that we don't think are ethical? I mean, no, not at all. Sorry, let me really moved on from my notes here. Right? Because, despite our awareness, we still embrace these tools, right? And Rob Horning writes about this last September. He said, despite the steady flow of complaints in more and more high-profile media outlets about surveillance capitalism, the way it erodes privacy, abolishes trust, extends bias, foments anxiety, and invidious competition, on and on and on. This is a great list, by the way. Despite all this, many people are still going to go with the flow and get the latest gadgets because, why not? Or, as some journalists have pointed out, it's actually impossible. I don't know if anyone saw this article. It's by Kashmir Hill. She took 5 weeks and had a whole team of expert technologists and a budget to try to figure out how to disentangle herself from these technologies. And she said she actually literally could not do it, right? So who has 5 weeks and a surplus budget to sort of disconnect? Not me, anyway. Okay, so... these were the things that I was thinking about, right? This leaves us with a lot of questions, right? Is technology bad? Is computing bad? Is Western civilization bad? Are humans bad? Is capitalism bad? Are we just totally screwed? What do we do with this information, right? And so that's what I was thinking about as a graduate student in the humanities. Thinking, maybe the humanities can help us out here somehow. I don't know why or how. And I came across this book. Does anyone recognize this book? A few people. Cool. Awesome. Yeah, Pedagogy of the Oppressed. I thought some of you might recognize it because even though it's a book that was originally published in Brazil, in the 1970s, it had a great, and still today, it had great influence on US educators here and sort of launched a movement called critical pedagogy. Anyway, I want to share a little bit with you about this book because even though it has nothing to do with technology, it's about pedagogy, right? Teaching, it's about education. It surprisingly and joyfully offers some ideas about how we might respond to the sort of technological dystopia that we see rising up all around us. So I thought I'd tell you a little bit about this book. It was written by a Brazilian educator and philosopher named Paulo Freire, who basically in the early 1960s was directing a national literacy program in Brazil that aimed to basically teach millions and millions of impoverished Brazilians how to read and write, adults essentially. And if you're not familiar with this period in Brazil's history, this was a decade of great political unrest. In fact, Paulo Freire's work was cut short in 1964 because there was a military coup and he was arrested and eventually exiled to Chile. But I wanted to show you these documents because I think they highlight sort of where the country was at the moment. On the left, this is a photo taken by an American photographer of one of a Brazilian rural poor child, and on the left is a still from a film called Vidas Secas, Barren Lives, which was one of the many films coming out at the time that was really illustrating the sort of struggles of these people. Okay. So while Freire was educating these people, he came up with this really interesting theory between education and oppression. And he says, look, so much of what passes for education is really, in fact, teaching people to accept the world view of an oppressive class, right? It's preventing people from questioning the status quo, from realizing their oppression, and for developing greater agency in their lives. And I found this little cartoon on the internet sort of depicting what Paulo Freire calls the banking model of education. And he says, really, what we're doing in the classroom is, the authoritative instructor is filling, the minds of students with this worldview and, orange Kool-Aid in this case. And then when you're done with education, you just think that the world is orange Kool-Aid. You're not actually asking, who is that guy? Why is he up there? What's the orange Kool-Aid? Why is he pouring it in here? Is there something, better that we could do in this case? So for Freire, oppression is denying people the right to critically understand and transform the world. And surprisingly, the thesis of his book, education is a very powerful tool in doing that. Okay, but it doesn't have to be that way. Let me look at time. Okay. It doesn't have to be that way. And so he spends his book sort of describing this different theory of education as liberatory practice. How do you teach people to not accept the orange Kool-Aid, to take off the aquarium, and to critically understand the world and transform it according to their own needs and interests? How do we teach people to have agency? Sorry, I'm lost. Okay. And surprisingly, as I was mentioning before, this book became very popular in the US, even though, the 1960s and 70s college student was, very different than the rural poor in Brazil at the time. And yet, sort of analyzing education for the ways that it teaches people to conform to the status quo is something that you can apply to educational institutions anywhere, right? Oppression does not need to be an explicitly violent act. And just for an example, right, the letter grade, that's something that we probably all think is sort of natural and neutral. You can also look at the letter grade and see it as a tool that reinforces individualism, right? That reinforces sort of competitive, self-serving interest when you're learning. And so, actually Santa Cruz, right? It has grades now, right? But historically, it did not have grades at some point. Is that true? Can anyone confirm that? Right? And that's really interesting because how is this grade teaching us to, go out into the world and continue to try to only serve our own learning and our own selves instead of working collaboratively with other people. We could talk all day about different ways ideological principles are embodied in education. But what I want to talk about is that I find these ideas really relevant to thinking about how computers have been adopted by higher education. And one observation I've made is that outside of computer science departments, computers have been predominantly adopted as just a neutral utility, as something to make the university processes, quicker, more efficient, easier, right? Think of learning management systems, word processors, email, web search, et cetera, right? In many ways, they've been, people really like these tools. They've made things easier to do. But at the same time, something really sneaky has happened, right? As we're adopting these technologies, as we're adopting the Apple II in the 80s, we're also adopting the sort of dominant view of computing at the time, right? Which is a black box form of computing where users have little expectation of being able to go into their machines and to change them according to their own needs and interests. Oops. And of course, you know, as I often speak to folks who only know this model of computing, right? But we're at a conference now where all of you are tinkerers. And so, of course, you know that there have, in fact, been many other models of computing throughout the years. The Scandinavian trade unions in the 1960s advocated for the rights of workers to co-design information technologies in their workplace. Alan Kay had this idea for a Dynabook where students would program their computers from the ground up. Ted Nelson, right? Any nitwit can understand computers, and many do. It's a good quote, right? You know, unfortunately, due to ridiculous historical circumstances, computers have been made a mystery to most of the world. I'm low on time, so I'm going to go quickly. The Free Software Foundation, of course. More recently, platform co-op movements. Okay, I'm just going to speed right ahead. And one thing that I think we've lost by adopting this, you know, dominant model of computing is we've lost the ability to give sort of the, you know, the larger student body the ability to creatively tinker with their tools. And one thing that's really interesting is you go back in the history in the 80s, and there in fact were a lot of educators and students who were not in the computer science department that were doing all sorts of creative things with their computing technologies. Do you want to see one? Yeah, okay, cool, good. Oh, sorry, before that, right? You know, they were aware of this because Fred Kemp says in 1987, why is it after more than 7 years of imaginative and innovative work by all these people on writing programs specifically, we still have this really boring, you know, word processor. You know, universities are just adopting, you know, word processors that are all about grammar and things like that. Okay, so here is one I want to show you. I'm really excited about this. There's many more. We don't have much time, though. So Hugh Burns, 1979. Hugh Burns was a graduate student in composition, and he created a writing program inspired by a philosopher, inspired by Aristotle. I mean, what does that even mean? And really, it's sort of a chat program. Students, while they're working on their essays, would chat with this bot and sort of develop ideas for their paper. And this is sorry, it's a sort of poor copy here. But one thing I wanted to point out is it's a joyful program. It's hilarious, right? Like here, he's talking at this point, or the computer is talking at this point with a student about their topic on the fear of death. And you know, the computer says, "Holy electronics, that's weird. I used to date a computer interested in the fear of death," right? I mean, how fun. So, you know, I hope showing this to you makes you realize, like, wouldn't it be great if everyone was developing weird writing programs based on their favorite philosophers or artists or, you know, things like that. So, right, I think we've sort of lost a joyful approach in computing for the masses. Certainly not for you guys, but for, you know, the broader population. But I think that's not the only thing we've lost. We've also lost a more kind of critical participatory relationship with our tools that is allowing really scary things to happen in educational technology more broadly, because all those forms of surveillance and control that we just looked at are also right now entering education, right? So the EFF just published this like 2 days ago. Schools are operating as test beds for mass surveillance with no evidence and no way to opt out. Let me just show you quickly a few of these. So I'm going to go quickly because I only have a few more minutes. But what is driving this surveillance? The value of student data, right? So in 2013, McKinsey Global Institute said, you know what? That student data could be worth as much as $890 billion to $1.2 trillion annually. That's a lot of money. And so companies, of course, are moving in on that. Have you folks heard of Turnitin, the plagiarism company, right? Has over 300 million student papers locked in on its servers. It sold last year for $1.75 billion to a media company, not even to an educational company. I don't know if any of you are aware, but Instructure right now, the company that provides Canvas, the learning management system, is right now negotiating a deal for $2 billion. And again, like the value of these companies, right? It's not just the software, it's the data that they have. Even our scholarly publishers are no longer calling themselves scholarly publishers, they're calling themselves, research analytics companies. And there's a lot of different, scary stuff here. I'm going to pass over. You can just look at it. Wristbands. It's too much. It's too much. Ooh, this one, Gaggle monitors all student email and digital communication, to make sure that you're not a threat to other students. That one's fun. Okay. Okay. What? Okay. What do we do? Okay, first I just want to tell you, look, I'm not the only person talking about this. There are a lot of really exciting people working in education or as writers or librarians that are doing really important work. This is only a few of them. Chris Gilliard, who's right here, he writes about this and says, actually, students are really angry about these forms of surveillance, but they just don't see any alternatives. If higher education is to, quote, save the web, we really need to enact, right, this better web in the classroom, and we're certainly not doing that right now. Here's Jessamine. Jessamine is up there on the left. Jessamine is a Vermont librarian doing all this really exciting library activism around digital technology. There's a hybrid pedagogy lab. Look, there's Paulo Freire right there. They're also thinking about more critical approaches to digital technology in higher ed. So here's a lot of projects. Digital Library Federation has the Technologies of Surveillance group. Okay, I'm going to speed along. What these are all doing, I think, is they're showing the importance of exposing students to different models and values of technological practice. I've been doing this kind of work too. When I was a graduate student, I helped develop a platform for socializing student writing and feedback. It was really fun just for that functionality. But what was really important to me is that it was a space where students could actually start designing the technologies that they were using in their education. And although we didn't get to enact this, it was sort of striving to also allow students to govern these platforms, to give them experience in sort of creating the policies around data and things like that. And so here's another beta or screenshot of the activity feeds and so forth. Right now, I lead a digital commons, a non-commercial digital commons in San Diego. For 5 different institutions of higher education. We have about 2,400 members, and it's really a place where students can create these discussion groups and create websites and things like that. But what I'm really excited about is that we have a student research group that gets together and we read about critical issues in technology and educational technology, and then we think about how would we like to further develop NIT according to our own creative interests and our sort of political concerns about educational technology. I also run Ethical Ed Tech with Nathan Schneider, who's at the University of Colorado Boulder. And this is a wiki and a learning community. The wiki is really a place where we invite the community to put information up about more ethical alternatives to technologies than the sort of surveillance technologies we see in education right now. We also do webinars and invite people working in this space to talk about their experiences. This was a really great editathon on strategic refusal where we heard from ed tech workers about their experiences in refusing to provide certain tools to universities based on the different types of surveillance they embodied. And what are the risks of that as an ed tech worker in refusing to do it, to provide a tool that your employer is telling you to use? And we also collaborate with other activists in this space. So Christina Kolkuhan wrote a petition to Instructure, that company we just talked about their use of student data, and that in fact got this EdSurge article written up about the concerns over their student data that I showed you just a minute ago. And then finally, another project I've worked on, where I don't think this is just about technology, I think it's also about raising awareness. So I worked with Autumn Keynes on creating this remixable student privacy statement that basically any educator could put on their syllabus to sort of just let students know that they should maybe be thinking about how their student data is being used by these companies, and hopefully just trying to not normalize the fact that we're allowing surveillance to just kind of happen in our educational spaces. Okay, so these are ways that I've been, trying to apply Freire's liberatory practice to educational technology. I see higher education as a site for liberating the technological imagination from the digital status quo. And what I mean just by liberatory technological consciousness is, the right and capacity to critically understand and transform the tech that we use, the belief that collective governance and development of technology matters, the study of the influence of this technology on our practices from the point of view of the users, not just the administrators, and the belief that technology is always an unfinished project, right, in need of our continued collective understanding and transformation. Why does it matter? Well, because we need students to be prepared to, shape a better digital future, and not this, not that. And I think, as I said, the imagination is a really important part of this, which is why I was so excited to see Rachel Carson quoted yesterday in the opening talk. She's talking about wonder, right? It's wonder, it's joy, it's imagination. We really need to preserve that vision of computing. And why I think it's so exciting that you brought up Rachel Carson, right? She, of course, is the author of Silent Spring. Are you all familiar with Silent Spring, right? It was one of the books that sort of kicked off the environmental movement in the US and sparked the imagination and made people care, right? And I think her work has really led to the profound movement that we see happening today. And I think we need something similar for computing, right? And this is what I think you all are already doing, right? By exploring the sort of joyful possibilities of what we can do with these tools. When you have power and agency over these tools, and showing people the value of that's really, really important. So what I just want to invite you to do is see, to see what you're doing as part of Freire's liberatory practice. And see that your joy of computing, isn't just for fun, it's for a better future. So thank you very much.
Thank you so much, Aaron. You gave us so much to think about. And I will quote Brianne Boland's tweet here, which says, really enjoying the mix of horror and inspiration from Aaron's keynote. Also, I reserved 2 books from the OPL and added 3 more to Goodreads in just the last 20 minutes, which feels fitting for a talk by a digital librarian. Can we have another round of applause for Aaron? Thank you so much. Awesome. We have a 10-minute break before we resume the lightning talks again, so we'll see you here back at 11:30. Yeah. And whoever's next, can you please come for AV check? Thank you.
this live. And we have had many people ask us if it's a machine doing that, if it's a neural network. But no, there's a live person from New York who is doing that. So to start off our next session, it's my pleasure to introduce Kathleen, who is a Santa Cruz local. Yay!
Okay, thank you. Can you hear me? No. No? Turned it on. Do I need to move it up? Maybe like that? Okay. Okay, thank you very much. I'm Kathleen. My pronouns are she, her, and I'm going to tell you a little story. It's part love story. I met my partner here at UCSC, right in the Baskin engineering area, in a computer graphics class. And one of the first lab activities was like bringing in an object from home and 3D scanning it with a structured light sensor. And I brought this like garden gnome that my roommate had that we called No Pants Dan because his legs were like flesh colored. But it's also a story of over-engineering my way into a problem and then like over-engineering my way out of it again. And it's also cameras and imaging sensors and things that make 3D models of things are super cool, and they've gotten like a lot better over the last many years. So we're going to learn all about that. So a little bit about me. I got my PhD in computer science from the University of Washington, doing collaborative photography and crowdsourcing 3D reconstructions through this game that I made called PhotoCity. And there's some other 3D reconstruction stuff in there. So this is kind of my thing, making 3D models of things, especially buildings and large spaces. So when I was getting married, I guess a thing you're supposed to do is have a cake and put a little thingy on top that represents you as a couple. So my partner and I were trying to figure out what that should be. We're like, maybe we should make a 3D model of ourselves. And the imaging techniques that I was using for my stuff were all like image-based. We needed a depth sensor, something that would work on humans. Conveniently, there's this guy, Richard Newcomb, who's doing a postdoc at my lab at UW. Here he is giving a demo of his Connect Fusion technology. And the way that Connect Fusion works is you have a Connect with a structured light sensor, and you kind of wave it around, and it fuses all of these different depth fields together that's seen from different angles into a single 3D model. So we're like, yeah, we'll do that. But unfortunately, Richard was out of town during like the few weeks that we had this idea to do this for our wedding. So we searched around online, and we found this company called Shapeify, where you could either go to a fancy booth somewhere, probably in Europe, and like get scanned and they'd print a model, or you could do like use their software and do some DIY Connect scanning, where you set up your Connect and you kind of like rotate in front of it yourself. And then you could order a 3D print from this company. So we're like, okay, this is what we'll do. So back to the computer graphics lab at UW now. We snuck in like the middle of the night with our wedding clothes on when none of my friends were there. And here's a test run, like before we put on our fancy clothes, of trying out the Shapeify software. Here's like a vine of a test run of the two of us, where we had to like stand very still and then like move in like 8 different directions, trying not to change our pose. But it made a model, and we ordered a color 3D sandstone print from the company Shapeify, and it came back like, oh, isn't that cool? Pretty cool. But I mean, well, this isn't going to get any better, but the lighting in the lab was like really crappy, just fluorescent, like school lighting, and the colors on the model were kind of green and dark and sickly, and I was like, this is just not aesthetic enough for my wedding. I don't like this. How do I get this data so I can reprint it? And I go to the website for Shapeify, and there's like no way to get the model out. But I could see this 3D interactive viewer that was on the website at the time. I was like, I can see the data. The triangles are in there. I know that they're there. Maybe I could have emailed them and asked them, but I was too shy. I wrote a program instead. And conveniently, like I've made some 3D viewers back in my day since like the undergrad class here. I made a Java-based point cloud interactive tracing thing. I made a streaming point cloud viewer based in Flash. I was like, maybe I could figure this out. So that's what I tried. This is what I did. It's a Shapify website. I inspected the network traffic. I saw like a big blob of 3D data coming in, but it was encoded. And I was like, I can't read this. So I downloaded a copy of the whole website, including the local JavaScript file to poke at and try to get it to decode the model for me. Somehow successfully did that and was able to print out the triangles and format them in a nice ply file of vertices and edges and triangles. And get the data. And as a note, when I was making this talk, now they have server-side rendering, so you drag a little box around and it makes the picture on their side, so you can't get the triangles out as easily. I don't know. So okay, we got the 3D model out. Yes, here it is. Great. Now I needed to print it. And at this point, there was 2 weeks, maybe less, before our wedding. So I don't think, we couldn't go to Shapeways or something, more pictures of the model. So we had to go to our local friendly makerspace in Seattle, Metrics, which is now closed, and we asked them for help. And one of the things about the model was that the Connect, the way that it worked, and my husband's shiny dress shoes messed up his foot. So a person at Metrics painstakingly reconstructed the foot for us, and that was really nice of her. And so we started it printing, and we went in there probably 11 o'clock at night, and it was taking a while. So we're like, okay, we'll go home. We'll come back tomorrow. And we came back the next day, and we saw our model in the little display case. And we're like, oh, is this a ceramics painting place where it's on display and you go pick it up and take it home? And they're like, no, we printed a second copy of you to keep for ourselves. It's oh, that's kind of like that Robin Williams movie where he keeps photos of a family when he's developing the film. Also looking at their Flickr stream, great, they took lots of pictures of their 3D print of us. So that was kind of nice to see as I was making this talk. So we got it home. Here's the color sandstone next to the white plastic. A couple different views of that. We made it a little bit bigger. Got details in the back. We put it on our cake. It all worked out. And as I was making this talk, I went back to the website. Now you can download the data for free since I already bought it. So I was able to, just get it and look at the color model, which I hadn't seen before. So that was convenient. And in the last minute or so, I just want to talk about it's 2020. This actually was done in 2014. When we had a Connect, what would you do now? Well, now there's a tiny little Connect in my iPhone these days. Literally, the structured light sensor that the Connect has, there's something like that in your phone. There's a little dot projector. It's how the Face ID works. And I didn't even put this together until I was like, oh, that's where the depth camera is. It's on the front of my phone. So I found some iOS app called Capture, and I was using it before this talk. And this sure looks a lot like the visualization of Connect Fusion to me, and makes a nice little point cloud. So I think if I were to redo this in this day and age, I wouldn't have to sneak into my lab. I could do a lot of this in the comfort of my own home. I could find a place with better lighting. I was very excited to make some models of my cat here. And, we had to find her when she was sleeping. So she was like, oh, you're waving a phone around. So with that, here are 3 of the tools that I used. MeshLab to look at 3D models of everything, Shapify, and this capture scan. And I also want to point out that this whole topic, this project grew out of my undergraduate education here at UCSC a long time ago with amazing TAs and graduate students. And at the time, they were getting paid enough to live here. Now they're not, so that's why they're on strike. And I urge you to support the grad strike here. So thank you.
Thank you. So they say testing is more important than writing the code itself. They say it, but like that, I think that applies to industry. I'm in academia, so I never have to test my code. So please join me in welcoming Matthias, who is going to talk about getting 100% test coverage by deleting all your code.
Okay, hi, can you hear me well? Just a second. Oh, the clicker. That's important. Okay, hi everyone. So my talk's idea starts one day at my company while reviewing our year-end bonuses. This is a monetary compensation based on the accomplishment of certain objectives the company had. So as any good employee, I'll try to find a way to automate this thing. Oh, not working. Oh, okay. To automate this thing, let's find a way to minimize the work I had to do, but maximize the profit I could get from it, obviously. So one of the objectives we had was to get 100% testing coverage in our product. And if we think this for a while, it seems that is an automatable metric. So I have this revelation that testing coverage is measured based on how many lines of your code are being executed when you run your test suite. So if we just delete every line that it's uncovered, that means that because the lines weren't tested or executed, my test will pass anyway. And because the lines don't exist anymore, we will get 100% coverage for free. So yesterday in Nick's talk, we saw how to write programs that write other programs. And today I'll be talking about how to write programs that delete other programs, basically. So to give an idea of what I expect my program to do, let's take this simple example. This is a simple if-else Python code we will be using Python. And we see here that the else branch of my code is not being executed in my test. It's not covered. So what I would expect from this tool is to, given the source code of the program and the coverage information, to delete the else, the oops, and this is not tested. Just no evidence of it. Or for example, we could have a function that its block can be tested, but it has some unreachable code. In this simple code, we can just remove the last two lines that we will have 100% testing coverage. So to do this kind of tool that involves source code transformation, I use the best tool at the shop to parse source code, that is regular expressions. No, just kidding. Please don't use regular expressions to parse source code. What I used instead was abstract syntax trees, or ASTs. An AST is basically a tree-based data structure designed to represent your source code. In this case, a simple hello world will be translated into a function call node where its childs are, for one side, the function name, and for another, the arguments to the print function that, in this case, is a binary operation where its children are the hello and the world string. So simple enough, this AST. So just using the Python standard library, it is possible to, when I have this tree that is, it's a syntax tree, but it's a tree essentially. So this means I can walk it and transform it just as we will do with any kind of tree. This simple code that you see here is trying to pass this print hello world into an AST, then it will visit each node in the syntax tree, and when it sees some bin operation node, it will hardcode the right part of it to the bang string. So in this case, the print hello world thing will be translated into this hello bang thing. One thing I want to mention is that the Python standard library has an AST module, but it doesn't allow me to convert this transformed AST back into source code again. So for this, I had to use this Google library called Pasta. I wanted to mention it because the maintainers have been extremely supportive. I had to report many issues because what I was doing was apparently kind of strange. So I hit a lot of corner cases related to indentation. But the maintainers helped me a lot and fixed all bugs almost instantly. So this is essentially what I had in my head, and I wrote a project called Magico that does exactly that. It's free software, it's GPL licensed because we should use more copyleft licenses. And it's not so tiny as I would expect before. I thought it was going to take me a few hours, and it turned out to be way harder because what I had to do wasn't just removing the else of an if or removing the unreachable code, but I had to deal with more complex AST transformations. For example, I had to deal with side effects in the if test expressions, or I had to deal with the Python yield statement that, because it transforms functions into generator functions, even when it is not tested, even with the yield line is not executed, it will impact on your source code, so I cannot just delete it. One thing I also found that was a bug in the Python coverage library that incorrectly reported my cover code as being uncovered. So when I deleted the line, my code broke because that was actually covered. And apparently this was related to a CPython optimizer machine bug. I have no idea what I did, but eventually I fixed these issues and we got this project. So I think it's time for a demo. Hope this works. Here I have, can you see okay? Or maybe, okay. Here I have a simple Python project I chose just because it has a fast test suite. So I will run its test suite to see, yeah, all tests are passing, just as we would expect. But if we see the report, it has only 46% coverage. That's not good. My boss wouldn't be so happy, but we have Magico to the rescue. If we, oops, I think I didn't have. Okay, I will. Yeah. I want to avoid any misunderstanding of the tool, so I just ran this and, oh no. Magico, what did you just do with my code? You messed it up. Yeah, a lot of deleted lines. No, this can't be good. But if we run the test suite again, let's wait a few seconds. Oh, all tests are passing. That's good. And if we see the report, then see, whoa, all 40% testing coverage. So I have time for one more demo. So if we think this tool, Magico, was designed using test-driven development, so it has a pretty good test suite. If we run it, all tests are passing, and it's 86% coverage. It's good enough, but not good enough for a 100% testing coverage talk. So let's run it, the tool. Yeah, here I have it. I did some code deletions here, and if we see, oh, I forgot to run the tool. No. Oh, I didn't run the test. Sorry. I have to run the test again. I see the report, and yeah, we just. So, thanks. We just magical. So. So, as I hope you got by now, this tool wasn't really designed to get a profit to get a profit. It was just an excuse to make a tool. It's useless, but yeah, it has no purpose, but it was really fun to do that. So what I want you to take from this talk is that the world is full of rational, useful, pragmatic software, but that doesn't mean you have to write useful software. This was really fun. I learned a lot of AST manipulation and source code transforming, and even if it's useless, I learned a lot, and it was really fun doing it, so I want you to encourage you to write useless software, more useless software. Thank you very much.
Thank you, Matthias. I just want to remind everybody that we have some unconferencing time today. What that means is you take time to meet people who are interested in similar stuff, talk to them. You can, there's a board outside. You can bring up unconferencing topics that you want to discuss, put them on the board, discuss them. We also have dinner sign-up sheets, and we have carpool sign-up sheets. So if you're leaving the conference today and you want to carpool with somebody over the hill or somewhere else or to the airport, you can sign up for that. I hope you had a fun time last night in town, explored some local places. There's some really good Mexican food places in town that you should try out. You can't go wrong with Los Pericos. And speaking of restaurants, our next talk is about how managing restaurants and managing memory is very similar. So please join me in welcoming Jordan to talk about memory.
Can everyone hear me okay? Yeah? Okay, sorry, still plugging myself in. I don't know if there are any Tex-Mex restaurants in Santa Cruz, though. It's more of like a Oklahoma, Texas, Southwest thing. Okay, so yeah, this is Tex-Mex and Malloc 3C, the problems that restaurant hosts and memory allocators share. My name is Jordan. I'm a software engineer. I have a lot of interest in system software in particular, so like operating systems, distributed systems. But my very first job was actually working as a restaurant hostess in a Tex-Mex restaurant, surprise. And this job taught me a lot, and I got really good at seating people from a wait to tables as people left. And I think about this problem all the time because it's actually kind of hard. We didn't take reservations, and this restaurant was extremely busy. So we would have like up to like 40 people waiting, 40 parties, so like 120 people waiting for a table in a restaurant that only had like 35 tables. And large parties do not fit everywhere in the restaurant. And on top of this, the place I worked at was very customer service oriented. So we would not turn down a party regardless of size. You didn't have to call ahead, like make our lives miserable, basically. And the way that we would make tables for larger parties is by pushing smaller tables together. And you might be able to see kind of where this is going if you're familiar with memory allocation. Yeah, so we also don't know how long people are going to stay. We can come up with some metrics to predict it. But as a host, which is what my job was, I had to interface with customers, managers, servers, all these people who kind of had different views of the world, as you might see. So what does this have to do with malloc? So memory allocators, if you're unfamiliar, take a region of memory and they split it up into pieces and give it to programs requesting some size. So you might request like 10 bytes, but you get like a 16-byte chunk. So it's not necessarily what you ask for, but that's how it works internally. And you can also do things like combine free memory regions back together so that you have larger pieces to give out later. And this is pretty similar to the problem of like taking small tables, pushing them together, separating them, and so on. So this was the literal restaurant layout. This is like how much I remember this, even though it was more than 10 years ago. It doesn't look like this anymore. I've been back. So the smaller ones are what we call two tops, which means they have 2 seats. And the larger ones are 4 tops, so 4 seats. And everything in this restaurant is small, as you can see. And then we can fit big parties in these sections. So like maybe table 10 and 38 can seat 6 to 9 people. This section down here was for those like people that would come in with their whole soccer team. So the way that we would operate when the restaurant was full is like, say maybe like tables 8 and 36 sat down at the same time. We know that they're probably going to get up around the same time. And we can kind of observe that too by whether they paid, et cetera. And so if table 36 gets up and we have a party of 6 coming up, we might hold table 36 so we can take 8 and 36 and push them together. So that's kind of like the idea of how this would work. And then this is a wait list, just an example, like names, sizes, time spent waiting, so on. So the rules, no one knows that reference. That makes me seem really, maybe I seem young, I don't know. So we seat parties in order of the wait. It's a queue, generally. But people typically understand if they're a larger party, like smaller parties can go ahead of them because they might be able to fit in different places. But in practice, we would actually announce the party's table being ready over a loudspeaker, so everyone in the waiting area can hear when people are seated ahead of them and will maybe notice. So I had to work with managers a lot. They would watch what we were doing, keep tabs on us, tell us what to do. And this is kind of like the way that they thought about the world simplified. They like to see tables seated if we were on a wait, because that means money, and if they don't, then we're losing money. And also, like, they have this special power where they can give free guacamole to unhappy customers and make them happy, which helps. Servers are another group of people I had to deal with who are making money by waiting tables. So they also like to have a full section, the tables they're responsible for. But they also really like high turnover because that means they're getting multiple parties, more tips throughout the night. And they don't like to be double or triple sat, which means sat with like 2 or 3 tables at the same time because there's a lot of work up front when you first get seated, like taking drink orders, saying hello, all those things. And this means that they really don't like big tops because we have to hold their tables, and also that might mean they're double or triple sat when we separate those tables later in the night. My incentives, though, as a host, are a little bit different. So I'm dealing with customers, and I like them to be happy. I like to not have them yell or be upset. And they generally like to see the wait seated in order. But they don't have that full context, so it's hard for them to tell if maybe a bunch of parties of 2 get sat ahead of them. They don't realize that those are only for tables of 2, and we can't push them together and give them that table or something like that. And I don't have free guacamole, which was a shame. So now we're getting to the good stuff. Allocation strategies and the properties of the system. So as seated parties leave, we have free tables. How do we allocate those free tables to parties on the wait? And how can we measure that effectiveness? Well, one of the properties we might look at is throughput. So that's the number here, the number of people served per unit of time, maybe like 400 people during dinner. And this can have direct impact on like sales for the day, which affects manager pay because they're compensated in part for sales, and tipped wages for servers who also get wages based on sales. Utilization, another memory thing. Percentage of tables seated at a given time. So like maybe for the average minute during dinner, 95% of tables are occupied. Lower utilization can probably mean that we're holding tables for big tops if we're on a wait. And that could have like impact on sales, but also large parties spend more money. They also have to pay like an extra fee because they're a big group. So maybe that kind of works out. The next is time to leave, which is how long it takes for a table to leave, so expire, whatever. Or table turnover, maybe a more reasonable thing to call it. But usually smaller parties leave more quickly. Low TTL is probably higher throughput, at least for that table, and that's going to be higher sales. This is a metric that I don't know if it's used anywhere else. I kind of just came up with it for this talk, but FIFO fidelity, first in, first out fidelity, as in how close are we to seating the wait in order. So like 65% FIFO fidelity might mean that 35% of parties were seated ahead of their spot. And the impact of this is a little bit more indirect because it's about customer perception. So that might make my job harder, and it might worsen how much customers come back if they feel like we're unfair or ineffective. Internal fragmentation, the seats used within a single table. So a party of 2 seated at a table of 4 is wasting 2 seats. And this is not necessarily like a bad thing if we only have parties of 2. That's probably the most efficient way to use it. But it was usually better to minimize this. So like maybe hold this table for a party of 4 that's a little further down and seat this table of 2 at one that's about to get up or something like that. External fragmentation is the number of tables that we cannot use for big tops because the seating times don't line up well. So if like table 9 has paid and they're about to leave, but 37 just sat down, we're probably not going to use that for a big top because we'd have to hold it until that party like ordered an 8 and left. And so this impacts FIFO fidelity because it makes it harder to seat big tops, in particular as the number of them on the wait increases and we have fewer options to put them at. So putting this all together, we know the incentives of each group of people and we know the allocation, or we can probably guess what the allocation strategy will be. How will this impact the system? So managers, they want to optimize for high utilization, so seeing lots of tables seated and high throughput, high sales. And this ends up looking a little bit closer to like a first fit strategy. So as soon as there's a table available for a party waiting, the first one, and seat tables as soon as they're free. But this can lead to higher fragmentation and lower FIFO fidelity. Servers look pretty similar. They like low TTL, high throughput, high utilization, also closer to a first fit. And want their table seated as soon as they're available, avoid double seating and holding tables. Again, higher fragmentation and lower FIFO fidelity. Hosts, on the other hand, are way on the high FIFO fidelity side, at least I was. And for low external fragmentation so that we have those spots for big tops. So we sort of treat them as special. And this ends up looking more like a slab allocation memory strategy. So we hold those tables aggressively, really reserve them for fixed size parties like 9 to 10 or whatever. And we also double, triple seat to make that happen in the future. So in an hour, they'll all get up, all these 3 tables will get up at the same time, and you can use it for like a 15 top. And that can lead to lower utilization, maybe lower throughput. It's all really dependent on what the wait looks like. And customers don't get to see people, but they might have a preference on one of these depending on their party size. So if you're a big party, you're definitely going to benefit from slab because you'll probably be seated in about the order that you came in, which is great. Come in with 12 people and get to be sat within an hour, that's great. But for smaller parties, you're going to benefit more from a first fit strategy because you will probably jump in the queue since you can fit at many more tables than big parties. So thank you. This is a good paper about slab allocation by Jeff Bonwick and a talk by Ryan Zazeski from Papers We Love. I watched it again before this talk to make sure I remember the details, and I work at Fastly. And that's the hiring thing, if you're curious. Thank you.
Thank you. So the next thing is lunch. It's ready. We have some excellent lunch from Cafe Iveta ready for you outside. So please have fun.
Is it time to switch out?
Hey everyone. Just wanted to remind people that our Lost and Found exists, and we do have a few items in the Lost and Found. So if you lost something, please check out our Lost and Found box. Our next talk is by Kate, who is presenting Of Muppets, Metaballs, and the Ballroom Dance. Please join me in welcoming her.
All right, and I'm your emergency speaker for today. They asked me to give this talk on Thursday, so I have not practiced nor timed this, but it does have a lot of animated GIFs in it. So prepare yourself. GIFs is the RC Cola of GIF pronunciation. It angers everyone. So yeah, a little bit about me. I'm Galaxy Kate at pretty much all the things. My pronouns are she, her. I recently graduated from UC Santa Cruz, so I'm now Dr. Galaxy Kate. I'm probably best known for writing the language Tracery, which powers a site called Cheatbots Done Quick. So I'm the proud grandmother of 10,000 Twitter bots that we know of, including Infinite Scream, the greatest ever Twitter bot. So that's kind of part of my mission, is to help people. Well, so my mission statement is I bring AI to people that AI doesn't deserve, because AI is a little bit of a trash fire. And I don't want to just like bring poets to it so that they too can live in the trash fire, but to take the tools from AI and bring them out to other people. And so I'm currently being generously funded by the Center for Research in Open Source Software, UC Santa Cruz, so I wanted to give them a shout out. I also brought a bunch of swag, so I brought those zines that are out there as part of my mission to bring cool tools to poets. I also have, if anybody has made bots, however you define bots, I have merit badges if you think you have earned a bot merit badge. And yeah, I have lots of zines. I also make just an absolute ton of weird prototypes. I almost never finish anything just because there's always new shiny stuff to be made. Yeah, just lots and lots of prototypes. But my research over the last 8 years, so I wrote this dissertation on something called casual creators, which I'll tell you a little bit about in a moment. But these are software that is for creativity, but not in the way that like Photoshop or GarageBand is about creativity or for creativity. Those are things that are for getting you to a product. Your boss says they want this thing. Your brain says it wants this virtuosic opera. They're all about the product. It turns out there's this other weird class of software. And I played a lot of KidPix back in the day. And the guy who made KidPix wrote this really lovely essay about what it means for him to have built KidPix and why he built it the way he did. And he talks about how the process of making a picture should be as important as the picture produced. If you're working for Pixar, this is not a thing to tell your boss. They don't care about your process or how you feel when you're making it. They care about the product. But there's this whole class of software that I think is really interesting because it is about the process. So I needed a term for this, so I called them casual creators. These are everything from like Burger King Simpsonify yourself, Simpsonizer, like weird doodly like make a cake pop apps, of course KidPix, any of the things where you doodle on your phone and it like kind of multiplies out your effort in interesting ways. Things where you can doodle music, you can doodle sound. Even things like Connects, where you're like not so much about making the thing, you're about like the physical pleasure of snapping things together. Rainbow Loom, if anybody's of the Rainbow Loom generation. But when I was writing this dissertation, and it took me forever, I had to go through a lot of like process of like, what is creativity? And we often say that people are creative. So like Mozart is creative and Steve Jobs is creative. And in my research, this seems to not be true. There's not a class of creative and uncreative people. As far as we can tell, everyone is creative. However, has everyone seen the movie Inside Out, like the Pixar movie? And like at one point, she develops this new superpower of disgust. There is, in fact, a moment in your childhood from about the age of 6 to about the age of 12 where you discover disgust. And it goes from physical disgust of I don't like broccoli to social disgust of I don't like this person or this activity. And then you see like other people being disgusted by you. And so if you ask a group of 6-year-olds, can you paint, can you draw, can you dance? They will all say yes, because at that moment they know can as the physical act. I can move my body, I can hold a pencil, I can make my mouth tell a story. If you ask 12-year-olds, or heaven forfend, 35-year-olds this, they all sit on their hands because they know that can you means can you do so without being disgusting to yourself in the world? And this is actually an issue. Like when you read about creativity, and you're not Steve Jobs, you read about people's fear of creativity. And so it's not so much about are you creative, but like what is currently keeping you from being creative? What is like your fear of creativity? I love this. Can I draw? How to tell if you're good enough? Like not even just good at drawing enough. Are you good enough? Do you have the moral fabric to draw? This is Calvinist art education. So a little bit about problems in creativity. These are just a couple of the problems that have been discovered. You can read any of the previous books on the previous slide, or just anything on Pinterest to say, like, what are the issues with creativity? There are things like being undirected, like freezing up, being trained to come up with the right answer. You know, are you good enough for this crowd? Like, is this the right answer? Is this what you wanted? Being afraid of negative judgments, running out of ideas. There's Winston Churchill after like World War II and being probably like one of the most powerful men to ever live on this earth, retired and started watercolor painting and was very bad about it. And he wrote a book about being bad at watercolor painting. And he has this anecdote in it where he is staring like in terror at a blank page. And one of his lady friends comes up in a car and like throws paint on it. It's like, now you can start. And miracle of miracles, it turns out he could. So this is not something that affects like, you know, people who are not good enough or creative enough or powerful or enough. Everybody has this aspect in their life. Winston Churchill being a very complicated example. But no matter what you can say about Winston Churchill, he was bad at watercolor painting. So I worked on a game called Spore way back in the day in 2007. And Spore had this real gem of something called a creature creator where you could like sculpt out a little creature and it would come to life under your hands. And we got really wonderful letters, like handwritten letters from people saying like, this game made me feel creative again, which was kind of like awesome. Like we were getting a lot of hate on the internet, but we would also like get handwritten letters from people who said like, I thought I wasn't creative anymore and now I know I was wrong. And this was designed with improv kind of knowledge because Chaim Gingold, the guy who designed this, was taking like improv, like high-level improv classes at Berkeley while he was designing this. So this is just like jammed full of every improv principle he could think of. And there's like books like Impro, which kind of laid out what improv would later be. But these are kind of like things like you give people prompts. You give people acknowledgement when they do something. Whatever arm or stupid accessory you put on your creature, it will look at it, and 9 times out of 10, it'll go like, yeah, that was really good. And you know, sometimes it'll be like, no, that was terrible, just to give you a little bit of feedback of like, it acknowledged you, it saw you. Yes, and this is the idea, like this is the most like caricatured bit of improv, this yes and is like, it sees what you did, it internalizes, and then it like adds something new, so now you have something to bounce off too. So the questions of, so I'm not going to go a lot into casual creators in today's talk, although I'd encourage you to read my zine about it, which is outside, or just ask me about it on Twitter. So the question is, how do we get people to be creative? How do we get people to move? And how do we get people to move creatively? So this talk is just going to be about like casual creators for dance or like ways to help people move creatively. And then how do we do all this with a computer? So let's do some improv. Raise your hand if you felt a sick feeling in your stomach when I said let's do some improv. All right. So first off, do something. All right, very good. Say something. Your hand is a puppet. Say hello to your neighbor. Name a Pokemon. Oh, the year was 1778. Yep. So, what did this teach us? Aside from the fact that we now know who the Canadians are. So we like to be right when we're answering. If there's not a right answer, we'll often freeze up. Reflect on when I said do something and you thought, like, is this thing that I'm about to do too big? Is it too small? Am I doing the right thing? What's my neighbor doing? Is my neighbor looking at me? Oh, gosh. Prompts are really great for this because they give us a few possible right answers. Or, they'll give us a prompt So like if I say your hand is a puppet, there are lots of ways your hands could be a puppet, but probably the right one is to do this. And then I've given you a prompt, say something to your neighbor or say hi to your neighbor. Then it makes it kind of easy to like say hello. There are lots of things that you could have done with that prompt, but there was kind of an easy right answer. And so that gives people just really two choices of like, go with the easy route or try to like add on to the easy route. And limiting people to two choices seems like a really strong pattern in this sort of thing. So lessons. Prompts can be verbal. Like I just gave you verbal prompts. They can also be props. I can hand you a shovel on an improv stage and say, do something, and that shovel will tell you what it was that the right answer is and kind of what your options are for creative writer answers. They can be music, so things like clapping or just like dancing to whatever beat is like, many of us have personal dancing styles, and a lot of those are just like event reaction to beats. They can be clothing. So this is things that you should not do to your cat, but this is apparently this was used in How to Train Your Dragon. They put a bit of tape on the back of a cat and use that as art reference. So when you add things to your body, it makes you move differently, and we'll talk a lot about that later. They can also be cultural expectations. So like the 1778 one is a very like, people have cultural expectations of what you say after that. YMCA is something that like, once you're trained into it, you can always dance that dance at every wedding you go to in the future. And like different subcultures will have, this is the dance that everybody can do because this is the dance that everybody knows how to do. And so it makes people who would otherwise feel terrified of dancing know that like, yes, I can do the hora, yes, I can do the YMCA, yes, I can do the electric slide. And you will do it well enough to not be disgusting to those around you. And again, this is like, everyone can dance. We're letting them know that they're allowed to dance. So one thing that I like to say here is clothing is an improv partner. This is one of the biggest things that I found. Everybody knows if you wear a cape that there are a certain number of cape moves that you can do. If you ever need to like do motion capture and somebody is like not moving enough, give them a cape, and suddenly they'll move a lot. There's a board called the Greatest Movie Capes, and there's like 60 different capes in movies that are great. So a cape is a yes and. Like I move, and the cape moves more in an unexpected way. It's a prompt, like I know that there are things that I can do with this cape. It's a prop, like maybe it makes me feel like I'm a superhero. It's a partner, it's reacting to my motion, it's making motion that I can then react to. And in animation, this is called secondary motion. This idea that like when you move, something else moves with you. And so like Bugs Bunny's pigtails, Ariel's tail, Bugs Bunny's ears, these are all like secondary motion. On Spore, we had a ton of secondary motion. We in fact had a whole secondary motion system called Wiggles and Jiggles that had like a full-time animator figuring out like when you move, should your antlers move? Should your legs move? When you run, should like your knees move more or should they be like kind of fixed? And so yeah, like we got a lot of interesting stuff out of this because the animators could make one animation, so this is their like internal animation tool. They could say like, okay, do the jump animation, and then say with any possible weird body morphology, how should that, like, what should happen then? So they could tune this very carefully so that stuff could move in a way that they thought was about right. So yeah, that's how humans do it. Let's figure out how computers do it. I had to have one awful AI slide. So now let's talk about dancing with the computer. This is not specifically what I mean, although this is something that came out, probably in the early 2000s of a ballroom dance partner out of Japan. But we can talk about types of human-computer dance interaction. I wrote a paper, like a very short paper, trying to at least tease these out. And as far as I could tell, there are like kind of 3 different ways that you can respond to somebody's body movements. There's costumes and wearables, which is like attached physically to your body, which are like immediate body-centric motions. There's fields where you're like disrupting a field of something. So like I'm walking through grass and the grass like parts and waves as I move through it, or I like, you're in one of those like lagoons with the bioluminescent bacteria, and as you move, like little sparkle flows flow out around you. And you can make that digitally. And then there's agents, where something is capable of acting on its own. And the questions here are, how does the computer listen? Like, what is it listening to? Is it listening to your body movement, your heart rate? How does it know your body movement? Is it just like looking for like, maybe there's a security camera and it's just looking for pixel differences, or is it actually trying to like figure out where your skeleton is? Is it listening to your voice, trying to match your pitch, things like that? How does it speak? Is it making visuals around you? Is it making the audio change? Is it physically pressing against you? And then the last one is kind of interesting because this is a lever that you can kind of tune. Is it a mirror or an agent or something in between? So here's a cape, our good old friend, the improv cape. But this is in Doctor Strange, and his cape is actually like a sentient being that fights him sometimes. And it'll change throughout the scene and throughout the choreography of like, it's just a cape, I can do things with it, to like, this object is physically fighting and is like a fight partner with me. So it's really interesting to watch that choreography. The one at the bottom is the Marx Brothers, where it's a classic comedy scene where somebody is like trying to hide from another person by pretending he's in the mirror, but imperfectly matching his movements. So you can have something where like, I'm looking at the computer and the computer is responding to me directly, and then it says stop, like I'm gonna do some improv here. So you can tune this back and forth. So let's talk a little bit about costumes. I do a little bit of dance. Like, I'm really bad at dance. I am just a casual creator at dance. I'm just like dancing well enough to be not horrifying to myself and others, or at least I have convinced myself that. But dance has this wonderful tradition of adding a lot of secondary motion, because as anyone in ballroom dance knows, you have you, your partner, and then you have all the flowing dresses around you that augment and basically yes and your motion. So you do a twirl and the dress says, wow, what a twirl. Or you jump and your fringe says, wow, what a jump. So like your outfit is your hype man. And like anybody who goes to raves knows that this is true. You have these flow toys. Like if you just saw somebody standing there dancing, doing this, you'd be like, wow, that person is not good at dance. But suddenly if there's fire involved, it's great. So again, this is like yes and for physical gestures. Some important things about like costumes, it's locationally, directionally, and temporally linked to the movement. So I do this and my sleeve should do that immediately. I shouldn't do this and then the computer chugs for a while and like 15 minutes later it's like, I figured out what to do. It should cause a very direct causal link. And the nice thing is you get kind of emergence when you move and these things persist over time. So like that cool like glowing shoe like time-lapse thing going on down there. I went to a taiko drumming thing recently, and I thought that was really fascinating because this is also, it's a dance form where you're hitting drums. And so they'll do this, but as the accent to that, the drum is almost like a wearable or a dance toy, where as you do this, then you get a big boom at the end. The one at the top is Fred Astaire doing a famous dance where he's throwing down those little poppers, and then tap dancing on top of them. So as his feet hit the ground, there's a snap of his shoe hitting the ground, and then usually there's a little explosion. So it's like taking the normal tap accessory of hitting your shoe against the ground to create rhythm, and like doing even more so. And now you also get like smoke plumes. I promised y'all more Muppets, so we're just gonna keep doing Muppets here. I hope everyone's okay with that. Muppets are really great because so a lot of this talk was inspired by a visit I did to the Atlanta Center for Puppetry Arts, which everyone should go to, and they had the Henson wing was open, and you could see all the Henson Muppets. And for the first time, I wasn't just looking through like a VHS tape, I was looking at the actual Muppet itself. And almost none of them are bare Muppets. They're never like bare felt. There are very few that are. Most of them all have stuff on them. They all have these dance accessories on them. And these dance accessories are props that tell you how to move this Muppet. Like imagine you had Janice over there on your hand, and you were like, somebody called in sick at the Jim Henson lab and said, you're a visitor, come here and you play Janice for the day. And immediately you put her on your hand and you start doing this, because her hair says do that. Like if you wear, I forget what that guy's name is, but you start doing this because his hair really wants to do that. These are like hand capes. They tell your hands what to do. And this is great because you can make people play with puppets very easily, and then you can also kind of have really new experiences. So there's an artist, Nick Cave, not that Nick Cave, who makes these things called sound suits that are really incredible. And then other people are doing digital animations on top of bodies to kind of have these like surreal secondary animation just all over the body. Cats does not do this. There is no body movement in cat, why? And just like one whole scene, like one whole slide of animal, because animal is the best. But look at all the different things that his hair is doing. So like, especially in this one, where it's like movement, 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 and then still, like as he's like coming to this revelation. And so like his hair and how it moves and when it's still and when it's moving is part of his character. Muppets have almost no facial animation. Many of them don't have eyes. Count how many Muppets you think have eyes and then look, and it's almost none of them. The Swedish Chef has almost nothing on his face. He's like a nose with eyebrows. And yet you would swear up and down you've seen the Swedish Chef blink. And again, it's all this secondary animation. So yeah, I actually got to play a little bit with this in a project that I did for Google Creative Labs. They had something that was kind of like the Kinect, but for a regular webcam, so it would be able to detect your body pose. The tech never ended up working out, and this didn't actually end up shipping, although I'll show you something else they made with that tech. But this was me trying to like interpret Nick Cave sound suits and Muppets into a digital costume that people could wear. Because the idea would be, they wanted something so that people could download an app, walk in front of their webcam, and then do something. And we know from before how bad do something is. And so I wanted to give them a costume so they walk in front of the camera, and suddenly you have very long arms. And imagine how you would move if you had very long arms. Maybe very long arms and a giant mohawk. Like you would move in different ways. And there's also a whole bunch of like mask theory stuff that you can go into of like, when you look at yourself and you're not yourself, you suddenly have wild freedom. You know, as exposited by The Mask, 1995, Jim Carrey. It's nonfiction, people. But yeah, so that's like another way to get people over their fear of creativity, is to make them look at themselves as not themselves. And so yeah, I had like a little virtual body, and this is just controlled with Perlin noise because the body detection stuff wasn't really working at that point. And actually at that point it was so secret I didn't have access to the pipeline of body data, so I just faked my own. And then you just remap that in weird ways with like different curves. And you can kind of accent the curves in different ways. And then I ended up with just, yeah, all these like weird body costumes that like follow your limbs in different ways. So one of these days I'll ship this when the technology like becomes more available. But yeah, the most important thing in this sort of project is immediacy. And the second most important is connection, like knowing that you have influenced the world. But that's often driven by immediacy. I did a lot of research on like various academic projects for like, there's a lot of generative dance out there, especially in the computational creativity community. I don't think they're getting it right. There are a couple of projects that are getting it more right, and so I wanted to show you a couple of those. This is Lumen AI, which is like a huge multi-person project out of Georgia Tech. And there's like a dome, and you're in there with a VR, like, or with a like virtual shadow that's like dancing. One of the issues though is that what they chose to do was not immediate. They decided to go very agent-based, where this thing is autonomous. So you dance for a while, and then you pause, and then it'll dance like you, except that you're not sure if it's improving or if the Kinect stopped working, or if it's just like doing really creative improv. So this has one of the issues that like, if you as the designer cannot tell whether or not the Kinect is plugged in, anybody who's been in this space, like making a really creative thing that like deals with some like input, and you're like, wow, it's doing it really well, it's doing it really well. Oh, the socket wasn't plugged in. Yeah, you can easily lie to yourself that like more improv is happening and not just like noise. This is another project from Google that did end up using that TensorFlow stuff. You can see kind of how janky it's following the body. So what they did was they very cleverly didn't do a continuous thing, although it feels almost continuous. It's just searching the Google library for the pose that most closely fits your thing. So it's like disconnected and kind of jank, but that's actually what it's like. That's very cleverly papering over an issue with the software. I'm running out of time, so I'll just go through this real quick. Oculus First Steps does some really great stuff improving with the robot, and then you get to hold hands with the robot, which is the only time I've gotten to hold hands with anything in VR, and it's amazing. And this is their demo thing that they get you right out of. It's awful. So the question is really, what is dance about? And there's a whole thing about like dance notation, and you have to notate what your dance is about, whether that's arm positions or physical positions or like where you are in relationship to your partner, which is that like ornate scrolly thing. And there's a whole book on dance notation that is fascinating to a computer scientist. But I do ballroom dance and swing, and so I think of them as like forces. The one on the bottom is somebody at Google did this, and they were assigned to do this, and they hadn't swung danced before. And so I was like, oh, here, let's swing dance. Like, see how it's all about like your forces, you're pulling back and forth. And so they ended up capturing that really nicely, so I felt helpful. So I do a lot of stuff with particles. These are all just like different particle experiments. And like, I do a lot of stuff with hand tracking. So if you ever do hand tracking, make yourself a set of like infinite virtual hands that just do this. And that way you don't have to like switch between that all the time. So I have a lot of like virtual hands that just like oscillate forever. And then just like particles that respond to those hands in some way. They're either following them or just kind of like attracted to them or generated from them. And so I'd had this game that I had made a while back called Falling For You that's dead from bit rot. But you had little particle people falling through space and falling in love and making like long polyamorous families, which is accidental because people have two hands, so obviously. And that was just like springs and particles. There's no like actual body animation in here. It's just like springs and particles and forces between them. Inverse kinematics is something that happens to bad people. Anyway, so I was like, okay, well, I can make a body out of that, and if I've got springs and particles, then I can add dance tribbles. And a dance tribble in this project, and I know I'm kind of out of time, so I'll like rush through the last of this, but I want to get into dance tribbles, because I don't want to just say that and leave. So imagine that you have something on your hand. It's a dance tribble. It's a little sentient being, and it likes bass beats. And whenever it hears a bass beat, it'll pull up your hand. And then you have another one, and every time it hears a bass, like a treble beat, it'll do something else. And so now you have like a rudimentary way to define force-based choreography. And so I started like making a generator for this. I had like genetic algorithm-based bodies, so you could like evolve little different like dance morphologies. I had a dance descriptor, so I got to put that in an like jazz hands in an actual academic paper. And then let's see if. So yeah, and then this is like applying dance tribbles to arbitrary meshes. And you can see that they're like mostly working out here. I'll let this go for like 1.5 songs. Come on, switch. Yeah. So anyway, you can see that like you can get kind of like different stuff going on. And so if I added that to that, I got something that in fact did not work at all. I will revisit this someday. So yeah, like we have more input devices than ever. We have like Kinects and PoseNet and Leap Motion. Oculus controls can now like listen to your bare hands, so you can do like fancy hand tracking. And so far, all that anybody is using them for is a button. Like, do this to press a button, do that to press a button, do this to press a button. They're not like responding continuously. So my question here, and this is just like a bunch of random stuff that I've made to respond to like hand tracking things. How would you make, so what is the future? I tried to search for VR puppets, and there's like that one up there, and then it's mostly scary puppets that follow you in the dark. No one is actually having you be the puppets. It's dreadful. And the one in the middle is the Waldo system, which was like basically you do this with your hand, and this is how the Muppets did a lot of their like long distance Muppetry. But we haven't like revisited that like 1980s technology, but now like with good hand tracking. So yeah, any questions? This was my talk. Meet me outside. We can talk more about Muppets, or I can teach you how to polka. And yeah, Max, who's in here somewhere, and I are doing a workshop in casual creators at ICCC in Portugal this year, if anybody has academic papers to send to us. But yeah, that was my talk.
Thank you, Kate. Right now it's time for unconferencing, and there's also coffee outside by the registration desk or where you registered. Enjoy.
Bye. Okay, so this is the penultimate section of talks, and we have Sarah Newen performing Link Rod, the dancing the patterns of digital decay. Please join me in welcoming Sarah.
Thank you. Okay, hi. Okay, this is gonna be breathy because catching my breath. My name is Sarah Nguyen. Thank you for watching and being part of Linkrot, Dancing the Digital Decay. I'd like to start with a big thank you to Rami and Ronnie. He made the music to accompany this piece. The music was streamed from Brooklyn, New York, and live generated from his Octatrack, based off of Rami. It was based off of all of yesterday's talks, so you might have recognized some of the voices throughout the piece. So we rely on links in order to share information, make data into something understandable, and create some sort of relatable knowledge base. When these relationships are broken, we lose access to data, information is incomplete, and knowledge is lost. This can be seen through 404 error pages, broken redirects, irreproducible systems, and decaying magnetic tape. This performance is an analogy for the bit rot and obsolescence that can happen over time as we upgrade and update technologies. Yesterday, I recorded the audio from all the talks and sent it to Ramin. Thank you all for letting me use that. CC BY. Got you there. And the music was intentionally made to start off as if we're building the internet. It gradually builds up to represent the supposed utopia of links, relations, and connections. The music gradually breaks down as people begin to exploit and disregard as those connections decay and become obsolete. The piece ends with a storm of irrelevant connections that should not have been formed, and closes with a lone hard drive spinning distant memories. I dance this because physical movement in dance is the most ephemeral medium, to me at least. We cannot easily recreate, document, or back up a muscle tone, a dancer's breath, wherever that breath is, or the dancer's relationship to the audience. I'm a graduate student for libraries, information science, and archives, and I'm interested in the rate of obsolescence of our digital ephemera and how we can, or if we even should, emulate or recreate technologies. I'm curious about what are the systems, code base, environments, or maintenance that are needed to ensure that people have access to this knowledge in the future. How can we document, package digital objects so that even aliens in the future are able to reproduce what has brought us joy? In the end, it's also important to consider that not everything needs to be preserved and everyone and everything has the right to be forgotten. Thank you so much for watching and listening, and support the UCSC student strike. Thanks.
Next, we have Jessica Gerson talking about how she solved her NYC parking problem with Python. Please join me in welcoming Jessica.
Hey, how's it going? Can you all hear me okay? Yeah. All right, cool. Hi, so my name is Jess, and I'm a developer advocate at Twitter. And I'm here to talk with you about how I solved a parking problem that I had in my life with code. And let me know if this inspires you to create anything. You can reach me at Jessica Garson on Twitter. And code for the talk today can be found at github.com/twitterdev/parking. Today we're actually going to be using a repository in there called Recent Search. So let's talk a little bit about what was happening in my life to inspire me to create a solution with code. So I live in Brooklyn, New York. And if you notice, the car has an orange envelope of sorts on it. That is a parking ticket. How many people have gotten a parking ticket in New York? So a couple of hands are raised. How many people have ever gotten a parking ticket? All right, the whole room has raised their hands. So in New York, that is a $45 to $160 endeavor, depending on where you park and the situation. And that's really, really a lot of money. So I had a problem. I had a car. I no longer have a car, but I did have a car. And I was moving my car a lot every night. I actually looked at traffic data in my neighborhood, and I would move my car every night at 8 o'clock. And I was really good about this. I had an alarm to remind me to do so. I would move my social schedule, so I would move my car right on time. And I was doing this every night. You might be wondering, Jess, why were you doing this? What are alternate side of the street parking restrictions anyways in New York? What is this? So Yeah, on Mondays and Thursdays in my neighborhood, you can park on the right side of the street until 8 a.m. when there is street cleaning that comes through the neighborhood. And on Tuesdays and Fridays on the other side of the street, it's the same situation. So I was moving my car a lot. And there was one night where I was driving around for about 2 hours, 3 hours, listening to a book on tape. And I came back home, and my roommate was like, Jess, where were you? And I was like, yeah, I was moving my car. And they're like, yeah, but after, like, what did you do? Did you go to a show? Did you go to a party? Like, did you do something cool? Like, and I was like, nope, I was just moving my car. And they were like, you know, you didn't have to do that. And I was like, what do you mean? I didn't have to do that. And they showed me this really cool Twitter handle called NYC alternate side of the street parking. And it updates every day at 7:30 a.m. and 4 p.m. And I was like, whoa, I'm a developer advocate at Twitter. I think I can like solve this problem. So I built a solution using Twitter data and Twilio to send myself a text message whenever I didn't have to move my car. So let's kind of talk about how I solved this. So I needed to get the tweets from the NYC ASP Twitter handle. I needed to see if the words suspended and tomorrow appeared in the same tweet. I needed to get a text message when the right words appear. And I needed to run this on a server so that this repeated without any effort from me, because I would never remember to run this script. So the process for creating this app is to get the tweets we wanted from the Twitter API, connect to Twilio, and get a text whenever I didn't have to move my car. So if you wanted to build something like this, you might be wondering, what will I need to get started? You will need to create a Twitter app, which allows you to connect to the API. You can apply for access at this address if you need that. The endpoint that I'm going to be showcasing today uses one of our experimental endpoints called Twitter Developer Labs, and it is recent search, which allows you to get tweets from the past 7 days. And you'll also need a Twilio account, and you can check out their documentation on getting started on the subject. Tilda is actually here with Twilio, and they have some really great example code as well, and you could talk with them if you need any help. And you'll also need the libraries twilio.rest, which you can pip install, pandas, and requests. So let's look at the code. I always like looking at code. So I have this running in a Jupyter notebook right now. And so the first thing you have to do is import the libraries that you need, which is pandas, YAML, and requests. So we can run that. And then we also can create a helper script. So you can actually get code that's very similar to this on an index card over at the Twilio booth. But from here, you'll import in OS, so you can use environment variables, import in Twilio REST and their client to help you connect. And you can create a function that I like to think of as like a secret handshake to create the authentication that you need. And then you can go and send a message. And so this is where you set it up. So you can say, you don't have to move your car tonight, enjoy your night. At one point, I had tweets. I had the full tweets going through this, but it wasn't really needed. So from there, you can actually import these two functions that you've created into the script. And then from here, let's actually run this. From here, we can actually pass in the handle that we're looking for into the URL. So we can pass in the NYC ASP handle, and we see the full URL that we're going to be connecting to. And then from here, I actually have a YAML file to keep my secrets in it. I make sure I don't push that anywhere, and I keep it in my git ignore. But I have my bearer token in there, so I can pass that through. So I'm going to go through the secret YAML file. And then from there, I can pass in that bearer token in through the headers using the request library for Python, and then do a GET request, pass in the URL, and pass in the headers that contain the bearer token. And so the next thing I have to do is figure out if the response encoding is correct, create an object for the JSON, print out that JSON, and then, when I get nervous, I like move my hands in weird ways. Yay, cool. And so we can actually scroll down here. We can put it inside of a data frame. And so from here, what we can see is that we have the data in a data frame, and we have just the ID and the last 10 tweets, which is pretty exciting. So we have, so we can actually see the the rules are in effect every day, except for on the 8th line and the 9th line. You can see that on actually line number 7, the rules will be suspended. So that's pretty exciting. Or actually, no, it's the 8th line. I did get it right. It's an older version of the code. And then when you do the client, that's where you connect to the Twilio API, and then you can put the logic in this one statement. So here we have, if the word suspended and tomorrow appear in the same text, then it says text sent. And then since it is not today, it will say not today, friend. However, if I move this and change it to the 8th line, then I should get a text message. And I do have a text message and 2 more minutes left, which is pretty exciting. So this is what the text message looks like for me right now. It tells me that I don't have to move my car. And this is currently deployed to a DigitalOcean server using a cron job. So the conclusion is, you might be wondering, Jess, why did you make this so you do get a text when you need to move your car instead of when you don't? And that's something that, like, every time I give this talk, people ask me, they're like, why did you build this whole thing instead of telling you when you did have to move your car? And that just wasn't the problem that I had in my life. So I challenge all of you to think about the problems that you have in your life and think about how you can create a solution with code. And if you want to see a blog post version of this talk, you can check it out at t.co/parkingpost. And let me know if this inspires you to create anything. Also, you can let us know at Twitter Dev or on the Twitter community forums if you get stuck or if you just want to tell us what you built. And if you have feedback while you're using the Twitter API, you can give us feedback at twitterdevfeedback.uservoice.com. And we're also hiring for a developer advocacy manager. So if that's something that you're interested in, come talk to me. And if you are building with the Twitter API and you want to talk, come find me. I'd love to have a conversation. Thanks. Also, solidarity to the grad workers.
Thank you, Jessica. Next, we have Tiffany talking about packages, but in 3D. Please join me in welcoming Tiffany.
Okay, can you hear me? All right, today I get to talk to you about one of my favorite things in the whole world, packaging design. It combines a few things I really love, including design, digital fabrication, code, and snacks. So some of the coolest examples of packaging design that I've seen are in the food industry, where decorative boxes are used to package things like cakes. So if you go to the art section of a bookstore, you can often find packaging diagram books, and they read like art books. So there's often very little instruction in them. They just have the diagrams and photographs of the final box that you'll be able to create if you learn how to assemble them. So the diagrams typically consist of 2 different types of lines: solid lines, which is where you cut the paper, and then scored lines where you fold them to create something like this donut box. People who get to create packages for a living are usually industrial designers, and they use professional tools like flatbed cutter plotters, which are on the order of $10,000. And the way they work is usually you print out your design on cardstock first, and then the machine holds the cardstock to the bed using vacuum or static, and you send it a digital file, and it uses a blade and a scoring tool so that you can then assemble your design, like this popcorn box. Those are really expensive, as I mentioned, around $10K, but there are more consumer-friendly options. So there are things like desktop cutters that you can get for around $200. They're even available at craft stores like Michael's, but you can buy them online, of course. And similar to the plotters, they have holders for 2 different types of tools, usually a blade and a scoring tool. And in this example, I've replaced the scoring tool with a marker so you can better see what's going on. So typically the process is you first do all the scoring, and then you cut out the outline of whatever package that you're going to assemble, like this rocket ship. So the problem I identified when I started working and looking at these packaging books is that typically there are images in the books, but they're not in a format that you could actually send to a machine. So how do you translate those 2D diagrams into something that a machine can actually understand? And that's where SVGs come in. So SVGs are an XML vector-based image format, and they're used in graphics more generally. So a lot of designers might use them to create vector artwork on the web or even animations, but they're especially useful for digital fabrication. You can open up an SVG file in any text editor, which is really awesome because then you could see exactly what the machine is going to do when you send it that SVG file. So we're going to walk through an example of SVG. There's always an enclosing SVG element that has some basic properties like the width and height of your design. And then the most common element within an SVG is a path. So let's walk through what a path looks like. Everything is with respect to a coordinate plane where the origin is in the top left. So if we look at this path, the first thing in it is M, which stands for move. And that defines essentially where your starting coordinate is going to be. So in this example, X is 10 and Y is 10. H stands for horizontal, so you just have to give it one parameter, which is how far to move in the X direction. So in this example, 90. V is vertical, so I'm moving 90. And notice that I'm moving down because Y is positive in the down direction. I'm moving 10 again, so I'm moving to X is 10. And then L stands for line, so you're drawing a line to the final coordinate, which is 10, 10. Which gives us a nice little square. Unfortunately, most SVGs are not that clean. So SVGs are often exported from something like a CAD program or a graphics program like Illustrator, and you might have thousands of commands in a packaging SVG or a packaging file like this one. So one thing you might notice in this SVG code is the command C, which we haven't covered yet. So C stands for curve. And it's pretty easy, actually. There's just 3 different coordinate pairs for C, 2 control points and an endpoint. So we kind of walk through this one. We're starting, again, at 10, 10. And then the last pair in the curve code is your endpoint. So my endpoint here is at X is 90, Y is 10. And what the control points do is they define the slope of the curve at the start and the end. So I can draw my first control point and actually draw a line between that control point and my starting point to define the slope of the start. And I can do the same for the end of the curve. And then what it'll do is actually draw a smooth curve through the start and end points, respecting the slope that you define through your 2 control points. So now you basically know how to read most SVG files at this point. So where I started with this process is I wanted to see what libraries already existed for taking image input, basically images from the packaging diagram book, and converting them to SVGs. So I found this library that's been maintained since 2003 by a Canadian math professor named Peter Selinger. It's called PoTrace, and it does exactly that. You give it this bitmap image, and it creates an SVG. So the first thing I did is then you have to take an image. So this is an image from the book. And you can open it up in any free software. I'm using Preview here, but you can use Inkscape, for example. And what I'm doing is I'm just removing the background and upping the contrast a bit so that the line work is as clear as possible. And then I built an app that's called SVG Tracer. It's a web app. And what you do with SVG Tracer is you upload that image that you've just cleaned. And then this is in real time, so it takes about anywhere between like 5 and 10 seconds to process that image. And then it gives you an SVG that you can export and send directly to a machine. Unfortunately, it's not as easy as just using the PoTrace output, because as I mentioned before, when you send it to a machine, you have to specify what is going to be scored and what's going to be cut. So I need to actually take that PoTrace output and separate the scoring path from the cut path. So I looked at the PoTrace documentation, and there's all these different options. And one of them, intriguingly, is called turd size. I don't know that much about image processing, but I figured maybe that was like a common term for image processing, and it's not at all. And I honestly think it's just like a math professor having fun. So turd size is basically specifying what size spec in an image to ignore. So I can use turd size, specifically a turd size of 25, to eliminate all the scoring paths from my SVG. So that's only step 1, because as I mentioned, I still need to figure out and isolate the scoring path. And what I did for that is I used this library called Clipper, and it lets you perform Boolean operations on a pair of SVG paths. So this is from their documentation. You could see I can switch between intersection, union, difference, or XOR, and then it will actually clip the SVGs relative to one another. So then what I do is I have this SVG of the potrace output, I have the SVG of the cut path, and I take the difference. That gives me the score path, and I can combine those two paths to create the final SVG. So with SVG Tracer, you kind of saw before I exported the SVG file. I can import it into a design tool. This is a proprietary tool called Cricut Design Space that is for the plotter that I showed before, the desktop one. And you can see that there are very clearly two paths, one for the scoring and one for cutting. And that makes it really easy to then tell the machine, use this path to use the scoring tool and this one for the blade. But wait, there's even more to this. So one thing that I won't be able to have time to talk through in completion, but I just wanted to briefly discuss because it was interesting, is when you look at the potrace output, it looks at the scoring paths as blobs. And when you think about a machine cutting around a blob, it's going to be really slow to cut hundreds of blobs compared to cutting straight lines. So what I wanted to do is figure out a way to simplify those blobs into lines. And what I did is I used this library called SVG Path Bounds, and I made some basic mathematical assumptions, and I'm happy to chat with anyone about what those assumptions were. But I wanted to test how much faster is it if you use these simplified lines in place of those blobs. So I went through the books, and I found the most complicated design I could find that has 75 scoring lines. And I cut it using my desktop plotter. And of course, there are no instructions, so I didn't know how I was going to put this together. It took me, I think, 6 times as long to assemble it as it did for me to fabricate it. But it makes this nice little cube. And what I did is I took many different examples from the book, and I wanted to see how much time do you save depending on how many scoring paths there are in the design. So for the sphere, there were 75 lines. And what this table is showing is the potrace default is basically, if you just cut a bunch of blobs, how long does it take? And the simplified path is, if you convert those blobs into lines, how much time do you save? And I found for designs where there are just a few scoring lines, it's kind of negligible. But when you have a lot of them, you can save up to 35% in terms of cutting time, which is pretty cool. So if you want to learn more about packaging diagrams, these were books that I highly recommend and I used. I think the first 2 are out of print, unfortunately, but I went to the Strand in New York, which is an amazing bookstore for art, used books, and they were there. Hopefully they're still there. I don't know. You could probably find them online, though. And this is a free app, so you can find it at this URL. And if you click on the fish and click the View Source button, you can actually view all the code. It's a Node app, so the things that are probably most interesting to people here is in the server.js file. So you can check that out if you want to learn more. And if you do anything interesting with it, you actually don't need to use it for packaging diagrams. You can use it just to convert any image to a bitmap. So I know a lot of people that use it for laser cutting, for example. So if you do anything interesting with it, please share it with me. That's my handle, scientific with 2 Fs. Thanks, everyone, for your attention.
Thank you so much, Tiffany. And the next talk we have is Cisco versus Cubed by Tom. Please join me in welcoming Tom.
Hello? Yeah? Okay. All right. So Project MC Squared was a TV program for kids where high school girl spies would save the world using science and technology. And the project had, or the TV show had a merchandise, and one of them was this fabulous pixel purse. And so, the pixel purse, it uses an LED matrix. So I didn't know anything about this until I saw this tweet saying that they were on sale for $6.16, coming down from the original price of $60. And that's really interesting because if you use the LED panel itself, even on AliExpress, it's usually about $15. So I've always wanted to make one of those really fancy LED cubes. And so you have a 2-to-1 aspect ratio for these LEDs. So in order to make a cube with those things, you need 12 of those purses. But Amazon had a purchase limitation. You could only buy a few of them. So I recruited my colleagues and organized a group buy. And 3 days later, these boxes arrived at work. And I love to think that there is a very confused data scientist at Amazon trying to figure out why a major graphics company is buying all these purses. But anyway. So if you look at it closer, I mean, it seems like it's fabric, but it's not. It's really a very ugly, hard plastic case. And then that's an aliasing thing, so that's just a picture thing. Anyway, but if you look inside, it's very simple. You have the LED matrix, you have some electronics, you have a switch, and you have 4 AA batteries. So in order to avoid trouble with my wife, because I already have so many boxes in the garage, I did a rapid controlled disassembly. And so basically, there is the loot, 12 panels, 48 AA batteries. I will never have to buy those again. And then a whole bucket full of screws and some electronics, including, I desoldered the components from that, 4 megabit SPI prom and some voltage regulators. Now, I'm not really a fashionista, really, and my hobby is actually field programmable gate arrays, FPGAs. And so these are pretty expensive for hobbyists, especially in low volume. But the way around that is to go on eBay and you find products that actually use FPGAs and then basically repurpose them for your own use. And so Cisco is one of the companies that really buys a lot of FPGAs. One of the major benefits is that they can use operating system updates to reconfigure the FPGAs with their own with bug fixes and stuff like that. Now, if you look at the board, it's really, you have an off-the-shelf modem that fits in a PCMCIA slot, and then the FPGA itself is used as glue logic to connect it to this HWIC slot, and that slides into a standard Cisco router. And so you can expand the router that is basically a LAN, you can make it a one, you can give it a one connection. So if you look at the component itself, you have the FPGA. Very important, you have a JTAG USB blaster pinout. That's a debug port. Then you have an RS-232 connector, some RAM, some unpopulated NOR flash RAM, etc. It's really very, very useful for hobbyists. So I set out to completely reverse engineer that thing. And this is the high-level block diagram. And now all the low-level details about how to program, you can find it on the web. It's on my GitHub. Okay, now the HWIC connector that Cisco uses is proprietary. And so what you need, I designed a small little PCB that converts this HWIC pinout into a standard 2.54 millimeter pin header, such that as a hobbyist, you can use that and you don't need to mess with these really tiny pins. And then if we talk about PCBs, you know, when I was a kid a long time ago, making your own PCBs was really a very nasty procedure. You had to use all these kind of really dirty chemicals. You had to shine with UV light an image onto a copper plate. Then you had to use other nasty chemicals to etch that away. And if you were really lucky and experienced, eventually you might end up with something that actually looks nice. And so I never got to it. But if you go look at this today, you can... I decided that finally it was time to make my own PCB, and today these Chinese companies offer prototypes for really cheap. And so I downloaded one night KiCad, and that same night, it was very late, I was able to upload a design to JLC PCB, which is the company I used. And 3 weeks later, a very nice PCB came out in the mail. And the amazing part is, it's $2 for 5 PCBs, which is just astonishing, I think. And then there's another $5 to ship it from China to here. So for $7, you end up with a professional, very high-quality PCB. And PCBs are an example of mass volume, low cost, and really high-precision mechanics, if you think about it. You can have the vias, they're like 0.2 millimeter in diameter. So think about what kind of precision you have there. And that made me think, well, you can not only use PCBs just for electronics, But what if you use it for pure mechanical stuff? I mean, I don't know how to use a 3D printer. I don't have a laser cutter. But maybe you can use PCBs to do mechanical stuff, and it has nothing to do with electronics. And as a proof of concept, I decided to design a badge for Bang Bang Con. And same thing, I installed Inkscape, uploaded the bitmap, converted to an SVG file, and then I used a plugin called SVG to Shenzhen that converts the badge into a PCB and then just produced it. And then this is the the badge. And then I gave that proof of concept to Josh, who really took it to the next level, and that's basically the badge you have around your neck. But it really, if there's one takeaway of this talk, I think is PCBs are so cheap and so easy to make, and you can use them for more things than just electronics. I mean, there's all kinds of possibilities I can't even think about. Anyway, so now we have everything in place for the cube. We have cheap electronics with LED matrix panels. We have a potential way for mechanics, so let's build something. And so LED panels, they have this weird construction and a very weird interface called the Hub 75. If you want to have like color shades and whatever, you need pretty precise timing to control every LEDs in some kind of serial format. And FPGAs are really perfect for that. So I designed on FPGA a driver to do that. And then I added also a soft RISC-V CPU on there, which then basically provides the pixels so that you can get your image. And this is the hello world of LED panels. And then and you can see there the FPGA driving that's a custom board at that point, and a prototype. So then comes for the mechanics. So I decided on a pyramid structure that was built out of 3 identical legs. And with a caliper, I had to be really precise in order to find exactly on the LED matrix panel where the holes are. Then you put those holes there, and I used these kind of right angle connectors things to basically solder them all together. And then basically that's the result from that. So here you have those things, and this will form the structure that keeps everything in place. And then it's time to assemble. So you start with 2 things, and you see everything around it, and then you just build it up. And to me, this really gave like the feeling of the Death Star tunnel in Star Wars. I think it looks really cool. Now, I only show you this once, this whole sequence. In reality, I did it about 4 or 5 times, and there's 60 screws in there. It takes hours to really get this right. And just to give you an example about why I had to do this, it's just to fix mistakes, right? And here's a good example. Here you see some of the LEDs, and in the middle you see that screw, right? And it looks fine. But when you zoom in, you see the problem. If you really tighten this, then you will get a short circuit between those 2 things. And again, there's 60 of these screws like that. So the solution was to basically use this 5-second UV hardening glue, and for each screw, put a little blob of glue on there and harden it, and now you have an insulation layer between the screw head and the thing, and basically you don't have issues anymore. And then this is basically the end result. You get something that looks really nice. You can get more information about it here. So I have a bunch of articles about it. You can look it up online. And well, now let's see if we can get this to work. Oops. Okay. All right. And here it is. Yeah. And that's it. Thanks.
Thanks, everyone. We have another break now, and I wanted to mention that we still have a lot of snacks on the table out here, including yogurt and vegan yogurt, so please help yourself. When should we be back, Joshua? 3:30. Please come back. Thanks.
welcome back. Welcome to the last session of Bang Bang Con 2020. What a great conference, huh? The next talk is by Maria. It's alive, but not for long.
Hi everyone, can you hear me? You can hear me? Can you? Higher. How about now? Okay, hi, I'm Maria. I'm based in New York, and I'm a game designer and VR developer. When most people think about virtual reality or imagine its future, so they usually imagine that. When in fact, my version of the bright future of utopian technocratic singularity looks more like this.
Landed on the ground, ready to go. We put to serve survival. United on the ground, we substitute no radiation. United on the ground, radio, we mix lava lavish. United on the ground, radio, take over with fallout. United on the ground, radio, we can mute mutants for you. United on the ground, radio, sing singularity.
So yeah, that was the trailer for my game, Bizarre Barber, that was actually released 4 days ago. Thank you. And this is how I describe my job in a nutshell. So instead of saying that I'm fiddling all day with very badly written Unity API, I just say this. I create sophisticated life forms. Like that. So yes, actually I was very lucky to get funding for the game, and the funding was tight. It was indie, and we had to make characters, and characters are hard on indie budget. These are all stages of like typical development cycle of like character for a video game, except as for VR, it also has to be very well optimized. So how to do this on a budget? Especially if we need to make thousands of them. Yeah, so in our initial game design document, we had this idea to have like roughly, like you saw these mutant heads coming at you, roughly 40, 50 mutants per level, and then it would be 13 levels, and then we'll have birds who are doing like fancy things with motion, then we'll have bosses, and then we have custom animals, and then we have 3D in person for all of that. So we needed to make about 1,000 of character. And we decided that computer magic will save us. ProcGen, computers, they're great at generating things, right? So we started in a very traditional way with the concept art process, started doodling on paper, and then we did doodles in VR. And then we started to make the first generative sketches in Houdini. That basically consisted of combined primitives. We combined them according to certain rules. Houdini is actually a very great 3D package for 3D modeling and visual effects and stuff like that. The good thing about Houdini is that it's basically a glorified spreadsheet. So you can model 3D things without even touching like a single vertex, without doing it in a traditional way like artists are doing that, you know, with like sculpting and drawing stuff. You can basically program all those things. So this is a head. This is the code for the head. So in Houdini, you program with nodes. Basically, every node is like some operation on a system level. And when you combine them together, it makes things. Only on occasion, we've been writing custom nodes. Basically, like most of the Houdini instruments are pretty well written for just make this. And here you see the nose. So this is like basically the structure, the rule, the description, the ideal platonic model of the nose. That was first test results, manual test results. So that was kind of like look and feel conception for the characters. We wanted to look them somewhat distinct, so they won't feel like they've been generated. We got some rules for them. Like even mutants need rules, 1 or more eye, 2 ears, eyebrows, nose, mouth. We plan to add some animation, so it has to be like well done for the smiles. Hair, it's a game about cutting hair. And to make things easier for us, we decided to do no textures and only do vertex colors. Then we have some rules for the game engine, because after Houdini, we had to import them into the game engine and set up for actual game. So and there are some rules for this. The main thing that was very important for us was the ability to replace or correct anything without exiting VR mode. So we basically made the whole level design in VR. And this is how the process of thumbnails work. So we import them, and then we do like little pictures of them. In Houdini, you can actually write in Python. So in addition to this, like in addition to this ready nodes, you can have your own nodes with Python. So for example, this is the code for a node that puts like custom glasses over things, and that those glasses are scaling with the eyes. And you can also write in Vex. Vex is like this weird like programming or expression language built in Houdini. So if you have to like write something really, really small, like for example, ramp map of the nose, so your nose can be like wider or shorter. So this is how you do it. This is Vex. So you can combine like traditional Python, you can combine very easy Vex, and you can also use built-in Houdini nodes. It's a very cool environment for programming because it's very visual. So for example, I find it difficult to conceive the whole system of code, but actually this way I can visualize everything. So here is a thing that we wrote in Python for generating the complementary colors. So we don't have to deal with, this like beautiful palettes. So Python did that for us. And here's the time. We finally had to generate Legion. So we set everything up, and then we set up like the seeds. You see these like little dots. Those are like every character. It's thousands of them, like literally thousands in this video. Okay, let's see. As you can see, the results are not that spectacular, not at all exciting or enjoyable. In fact, maybe less than 1% resemble something close to the actual living beings. And it was very hard for me to separate good from bad because, in fact, this process is the opposite of creation. You curate something, and then you have to retire the rest. And when I say retire, I don't actually mean they're being sent to Florida to live in a nice condo, no. I'm just erasing them from existence. And this is the opposite of creation, and I didn't like this process at all. Unfortunately, I found this wonderful article just like a week ago. It explains, like outlines all the reasons why generative design is doomed to fail, basically. So we won't have generative buildings in the future or generative anything, because people are not just, they just don't like that. It just like seems very strange and uncanny. And here is some takeaways from our process. Quality doesn't substitute for quality, and becoming a curator is actually very dangerous because curators are biased. They're human beings, so when I start curating those like good ones, they all look the same basically, and they weren't like diverse or different at all. So here's the process of fixing our mistakes. So first of all, we switched to the manual generation. We still had a generator, but now you can work it all like with your mouse basically. And it was like a big increase in quality, as you can see. Then we started to do some more playtests, and we discovered that people actually liked repeated characters more. And every character shouldn't be different. They like this, like forming this in-game bonds. They enjoy the predictability of these patterns. We engaged the community into the design. So we asked them, how can we make the generator better, and how can we generate more diverse characters? And it was really cool because people started to design characters that looked like them. And we ended up with such a widely different creative ways to do it. This is before and after, so you can see that they helped tremendously. The last step that we attempted in fixing our mistakes was adding MIDI controllers to this process. to make it more fun, more accessible, and the best part of it that you can actually do it as if you play music, and you can do it together with other person, so you can collaborate. So this is real-time generation basically, and in terms of time, it takes you maybe like 3 or 4 minutes to make a character, so it was still very, very fast, and we had like not 1,000 but 200 of them. So this is the slide with the tools and resources if you want to start it. I bet you all have wonderful programming skills, and you can utilize them in Houdini. You can program your art, and it will be beautiful. Most of the tools are free except Houdini. Houdini is also free for non-commercial use, but for commercial use, you can buy it for a little less than $300. So my takeaway is eye-opening revelation. Computers are cool and exciting, but what's creative, warm, and nice people work together. When creative people work together with computers, it's even better. So the last one is this. Give me your cards, I will give you a kiss. I can give 5. Thank you.
Hi. The next talk is by Naomi. Please join me in welcoming them to talk about neural net inspection.
Okay, is this working? Okay. Okay, so first let me talk about myself for just a second. I'm a current PhD student in natural language processing at the University of Edinburgh in Scotland, which has its own strike going on right now. Solidarity! I'm currently interning at Google temporarily in New York. I dictate all my code because due to a disability, it's hard for me to type much. My roller derby name is Gaussian Retribution. And my Twitter handle is nsafra. And I just got a tonsillectomy 10 days ago, so normally my voice sounds authoritative but alluring, like a sultry James Earl Jones. But today I sound like a Muppet. All right. So there are a lot of kinds of deep neural networks, right? So the simplest kind, the first thing they'll introduce you to is a feed-forward neural network. So you have an input x, that's some vector, goes into some function that involves some matrix multiplication followed by some nonlinear thing. The output from that goes into some other function that's a different module, and eventually you get your generally like a prediction vector y hat. There are other kinds, like recurrent. Recurrent networks are like you can iterate over a bunch of items in a sequence because the same module gets repeatedly applied to each item in that sequence. Okay. They can work in parallel. They have like, generally, x is not actually going to be a vector. It's actually going to be like a matrix because it's processing a bunch of inputs in parallel. So, generally you have your forward pass, which is what happens during inference when you're trying to produce output. So it goes in, it goes up the computation graph and produces your output.
And then when you're training, you're taking the derivative of the error and you're passing it back through each module, so you're training the weights of the matrices that are inside those modules down to the bottom. So I want to look at what's happening, during my training or inference time, like while it's running, right? I want to see what's happening with the representations. Maybe I want to save some heat maps of the different activations. Maybe I want to look at the concentration of gradients, which is something that indicates whether your network is kind of memorizing as opposed to learning a general function. Maybe I just want to see the magnitude of the error at each module. But all I have is inputs and some PyTorch modules that are trained or not. So what am I going to do? Hooks. Yeah. So what happens with a hook is it's a function that you associate with a particular module so that when the actual function of that module gets run, it simultaneously passes its inputs and outputs to the hook. So this is what would happen during a forward pass with a forward hook, right? And this is what would happen during a backward pass with a backward hook. So in this case, the gradients or derivatives are actually getting passed, both the gradient at the input and the gradient at the output are both getting passed to the hook. So it gets both inputs. But that's actually a lot of basically raw data that the hook is getting passed, and the type of that data is just like matrix, a tensor that's got this dimension and this dimension and this dimension, and you have no idea what any of them are doing, usually. So I have a little trick that I use, which is that I set every single hyperparameter associated with some dimension to a prime number. So even if two of them get collapsed, if you've set something to 3 and something to 7, and then you get some kind of input that's like dimension 21, you know where that number came from. You can just reshape it accordingly. So in this case, you can tell where each of the, this is I'm just using a dummy hook. The dummy hook that I wrote just prints out the actual, information about the input and the output types. And you can tell what hyperparameters are associated with what types. But then it's I've got that transformer model from the beginning. There's so many modules, and am I really going to have to add a hook for every single one of them? No, you can just add them recursively, actually. You've got this little function named children. So named children is just going to find you all of the child modules of a particular module, and you can just recursively go through the entire computation graph like that. And that's what I like to do because I don't like to manually associate a hook with each module. All right, I'm going to just end by talking about the grossest thing I've ever done with a hook, which is that there's this model, long short-term memory networks, LSTMs. PyTorch makes it completely opaque what's going on inside, but I really wanted to look at what was happening in the gating mechanisms, but I didn't actually trust myself to write an LSTM module that was definitely going to give the same outputs as the real one. So I just wrote an LSTM module that ran at the same time as the real LSTM module and just asserted that the outputs were the same. And that's the most disgusting thing I've ever done with hooks. That's my confession. And actually, that's it. Kind of rushed through that. Oh, yeah. Everyone heard me say I rushed through that.
Helpful time. Hello.
Yeah, you can also. And now for the last talk of Bang Bang Con 2020, join me in inviting Lee.
Good afternoon, Bang Bang Con. I'm super excited to be here to share some adventures I've been doing in drag makeovers using facial models in AI, and they're all using the facial model style GAN, and Flickr Face's high quality data set powers this person does not exist.com, which you may have seen. It's quality faces generated from a data set of 70,000 people, and they're all realistic, and they're all generated kind of on demand. The ecosystem of StyleGAN is flexible enough to support drag queen makeovers out of the box, and there is a publicly available demo of it. It took a lot of work to do, so maybe it's worth thinking about ways to make it easier. StyleGAN uses some ideas from style transfer and kind of progressively growing networks to separate generating backgrounds of images from foregrounds of images. If you're doing faces, you can kind of separate a blurry background from like your eyes and your teeth and whatnot. And you can smoothly interpolate in the 9,000 dimensional space it works in. All of these faces are somewhere close to the zero face in this 9,000 dimensional space. The code's available. The training data is available from Flickr. There are several pre-trained models available. And if you have a week or so on a machine that costs $25 an hour to run, you too can make your own models. If you want to generate your own training data, it's even more expensive. And the idea is that it comes from 70,000 faces extracted from Flickr. They're all 1024 by 1024. They get aligned and cropped in various ways with statues and paintings and photos pruned out. So there definitely is a bias in that, but they say it contains considerable variation in terms of age, ethnicity, and image background. There's good coverage of accessories such as eyeglasses, sunglasses, hats, etc. These are 7 sample images, but accessories are more than just a pair of glasses. Well, the idea is that when you're encoding, you crop an image to a face, you choose a loss function, as we saw in the last talk. You have to gauge where you are with where you want to be. Is it just have your parameters exploded to a prime number close to infinity? Is it the just sheer pixel difference? Is it some statistical model? And once you know how to improve, there are ways to optimize where you are. And the zero face that you want to, that a lot of facial models kind of hem towards, a lot of the models from this person does not exist, keep pretty close to the zero face. It's possible to get kind of glitch art if you go too far off, but you also don't want to stay too close to that. Maybe you want something more exciting. Maybe you want Ezra Miller's Seven Eyes from the Met Gala in 2019. Maybe you need Tina Martinez's adversarial poinsettia fascinator with industrial holiday cheer gift bows. That didn't register as a face, even though we can all see it is. So I'd attempted to compile some faces of reasonable photography subjects that seemed worth including. PR is welcome, and I'd attempted to encode all of those, and I plotted the loss over time of encoding it compared to encoding that zero face. There are 3 selfies I took with a just like webcam in my office, just like waking up in the morning, and then there's Billy Porter as the sun god with more of a loss. You can see he's resplendent. So that's interesting because it is proportional to how well you conform to the training data, which is great. If you feel like going out and being a bit more genderqueer, you can take a selfie and see like this is too close to the average of 70,000 people on Flickr. So this is a way to just shift it up a bit if you're in control. If you're not in control, if that runs on a CCTV, this is a bad idea. But either way, running it is expensive, and it's tough to model like a sun god look. Bob the drag queen's like blue wig, hoop earrings, and a snarl like a smoking water pistol and whatnot. And there are ways of kind of seeing how the end product maps to the beginning, and you can see ways that that the encoding progresses over time, and it makes more sense if you see it kind of exponentially sped up, because you need to run it a lot longer than you would expect just to converge to something that resembles to what a human observer would consider to be a reasonable encoding. So the point of this is that there's a lot of ability to do vector space manipulations. The original StelGAN encoder I used had 3 dimensions. One was age. You add age, and it becomes younger. You add gender, and it becomes more butch, and you add smile. And no one really needs to have a computer tell their selfie to smile. And all of those are straightforward enough, but why not try a dimension of a performer into and out of a costume? So why not a drag makeup tutorial? Furthermore, if you have computationally defined what a makeover is, you can say, how do I look out of the drag I've got on? So you can go in the negative dimension, which is not exactly intuitive, but that's how that goes. So here I am doing a Trixie Mattel look, going into and out of drag. I've got like a C-3PO Zinc robot fantasy knockoff, and either way, I've got kind of a Chernobyl like skincare routine when I'm going out of drag. But it's not immediately clear, seeing this, that what I'm doing is going into a Bob the drag queen look. And what we can do is we can take a selfie that I just did a moment ago, and it's up. That is a zero face of StelGAN 2, and it is uploading as far as I'm aware. Doing a thing. So that is up. Not well. All right. The demo gods are not with me. let's get. There we are. So I've got a selfie. I've got the dimension from Brian Furcus to Trixie Mattel. That is the same human being in a lot of makeup. And I'm encoding right now. You can see it kind of progressing slowly. This is me going out of drag. This is me going into drag. It's not exactly like prime time quality, but you can also see that there are that it gets kind of glitch art if you go too far. If I go 110%, there you've got Chernobyl skincare routine, and you've got kind of turning into plasma. So don't turn into plasma if you can avoid it. It's not very sanitary. So there are a lot of uses for this as kind of fun glitch art, like ways to do a makeover. It's also worth thinking about kind of larger scale impact, though, because this is all fun and games, but it takes a while to curate a data set, to provision GPU machines, and the GPU machines are super expensive, to tweak all the parameters, and this is not just for computer vision. We've invented 180 voices in Google Cloud text-to-speech, and they're either male or female. And the California state ID is more gender diverse. How often does that happen compared to like voices cooked out of thin air? So rather than doing like homophobia whack-a-mole, why not analyze the field as a system? And Donella Meadows in '97 published 12 leverage points of kind of places to intervene in a system with varying amounts of leverage. So the first one, you just kind of tweak the hyperparameters. You like encode it for twice as long. You change your models and this and that. And that's effective, but not as effective as tweaking the buffer sizes. So build new facial models, build new notebooks with more inclusive training data, which is effective, but not as effective as varying the structure of material stocks and flows, like using diverse data sets or having diverse hiring practices, which is effective, but not as effective as the delay per rate of change. So run a continuous integration benchmark to assess kind of how inclusive your encoders are, which is effective, but not as effective as like slowing negative feedback loops, and slowing positive feedback loops. So file PRs to make your AI more inclusive, but and fix bugs and add features in inclusive projects, not to the exclusion of other projects, but which is effective, but not as effective as structuring information flow, so raising awareness of systems, of issues of inclusion, which is effective and not as effective as changing the rules of the system. So like amplifying of voices, raising awareness, or putting on some adversarial fashion to insert junk snippets from the Fourth Amendment into license plate scanners, driving around. So step 5 and step 6 and 5 are what we're doing right now. 4, kind of organize system structure. So make a culture of open data, have reproducible results, and be aware of how things go, and change the goal of the system. Like maybe AI should be more inclusive and ethical, which is effective, not as effective as break down the mindset and paradigms of this system and challenge anomalies and failures of assumptions. Like, where does the training data come from? Like, are human benchmarks the best benchmarks? GNU freedom 0. Should you have the freedom to run the program for any purpose on a drone with a gun? How about sensitive groups? How are sensitive groups impacted? And after you've got that there's a lot of power to transcend paradigms. So like if you teach people to code, if you drop the price of GPUs massively with like Google collab and whatnot, then there are ways of decentralizing advancement of queer liberation. So thank you, and let me know what you think. It's been super exciting. Thank you.
Thank you, Lee. And with that was the last talk. I would like to welcome Joshua to give our closing remarks.
Do I have a microphone? I do. All right. Always bad news when you give me a microphone. No, I'm kidding. Thanks for coming. I have some prepared remarks, but the worst case scenario is that I'm going to ad-lib, and that's about what's going to happen. I don't know. I feel like there's been this theme today of empowerment. So we started off with Erin's talk, in which she told us about the kind of consequence of disempowerment, of not being able to control your computing environment, and what happens when people are no longer, when people, this keeps resonating in my head, is Canvas is something that you're not allowed to control, and as a result, Canvas controls you, right? Canvas is used to take power away from people who are organizing on this campus. Later, Kate told us about casual creators and empowering casual creators, and what does it take to take away, there's a word that Kate used, and it's transmogrified in my head to disgust. I was going to say shame, but it's disgust. And so right now, Lee provides this bookend at the end of today to tell us, here are 12 concrete steps. Here is something that I had never heard of, and applying these directly to kind of the model of how we operate, the model of things that we can do in the computing realm. So I'm just delighted by that. So I wanted to share my delight with you. So that's my ad lib. Here's my prepared remarks. The closing of Bang Bang Con is this kind of emotional moment for me. It's been putting together a conference is a lot of work, and it's kind of this moment of like taking a breath, and that's nice also. But it's also this closing, this feeling of Bang Bang Con. And so I'm gonna bring out this quote again that Lindsay had earlier from Rachel Carson. I should ask that her gift to each child in the world be a sense of wonder so indestructible that it would last throughout life, as an unfailing antidote against the boredom and enchantment of later years, the sterile preoccupation with the things that are artificial, the alienation from the sources of our strength. That's the gift of wonder. I wrote in my blog, which you are not expected to read my blog. I wrote in my blog a few months ago about the Bang Bang Con feeling, and at the end of Bang Bang Con West last year, I spoke a little bit about how we create this space together. And so here I am like a little bit nervous to bring this here because what I wrote there is like to a little tiny audience, and now I have all of you. And so like this is kind of like a personal, like, do I take the moment here to bring in like my religious and ethnic background and all that kind of sort of stuff? I'm going to do it because that's what we do here. I'm glad, and I've kind of been hearing side conversations all over of people who have brought more than just their technical background to Bang Bang Con. So I have this kind of story, and there's this, in the Jewish tradition, there's this idea of, so on Friday night through Saturday, that's the rest day, the Sabbath, Shabbat, whatever you want to call it. And there's this concept of the Shabbat spice. When you, on Shabbat, you make, or you, in my family's case, you buy challah. It's a specific bread. And you can make that any day of the week, right? It's not, I mean, it is a pain to make, that's why I don't make it. But you could make it any day of the week. But it tastes better on Friday night. And you can get it any day of the week, right? But it tastes better on Friday night after you've turned out the lights. And why is that? And so the mythos is that there's this special ingredient called the Shabbat spice. There's this special ingredient called the Shabbat spice. And so this ingredient, I'm going to quote Lindsay again, who said earlier that it's not frivolous for us to be here talking about joy and excitement. It's essential. And it's not frivolous to take the day of rest, right? It's essential. It's not frivolous to have Bang Bang Con. It's important that we have Bang Bang Con. So right, and even, I will say that even like relatively non-observant Jews like myself will periodically get a whiff of the Shabbat spice on Friday. So Bang Bang Con to me has that feeling. It's this kind of special moment that comes around once a year. And so the closing of Bang Bang Con West mirrors, in my mind anyway, mirrors the closing, the end of that last day of, that last hour of the day of rest. And there's this ceremony, Havdalah, where you kind of sing and you chant. And it's halfway between mourning that like, now we are going to go back to our normal day. But also it's this moment of hope that we get to take that kind of that special feeling and bring it back with us. And there's this weird thing, a lot of Judaism is not messianic, like the savior kind of thing. And Havdalah weirdly is. And like every time, like last week, I went back and the world was still kind of gross outside. And the week before, I went back and the world was kind of gross. But this week, when I open my door and when I turn the lights back on, then like maybe it will still be Shabbat outside. And maybe this year, when I open the door, it'll still be Bang Bang Con outside. And so I don't know. I kind of have that. It's this very emotional moment for me, the closing of Bang Bang Con, as I prepare to open the door and see what's outside. And so it's kind of just like this last moment is a moment to savor it. Anyway, that's my thing. So here's my list of thank yous. A thank you to you, our audience. Give yourself a round of applause. Many of you are here for the first time, and that's great. Welcome. Thank you. Thank you for coming to Bang Bang Con. I hope you enjoy this. I hope you take this outside in the world with you. Some of you are back at Bang Bang Con West for the second time, and that's exciting. Lindsay brought this up earlier. We were talking about this earlier, and that's exciting because now we're starting to build a community here together of people who like come back for this again. So that's great. I wanted to thank Bang Bang Con's past, who set the stage for this, and Bang Bang Con's future. And so that's my opportunity to tell you that the call for proposals for Bang Bang Con 2020 closes tonight anywhere on Earth time. Is that correct? Did I get that right? Right, yeah, so that's the case, okay. I have sponsors to thank. There are sponsors. Our phenomenal sponsors, UC Santa Cruz, Baskin School of Engineering, and the Computer Science and Engineering Department. They provided this venue in kind. They gave us a bunch of money with which we bought all sorts of like the custodial services, things like that. So they gave us a bunch of money. And there's a whole bunch of folks in those departments who put in, I'm going to hold applause for sponsors all until the end, by the way. There's a whole bunch of folks in those two departments that helped us out. Lightstep so they brought 3 incredible people, and I'm so glad that Lightstep joined us. They sponsored, not only did they come in at a phenomenal sponsorship, they sponsored the delicious falafel lunch yesterday. They've sponsored captioning, and let's see. And so the question is, one question that I had is, who and what is Lightstep and why do you need them? And the answer is observability if you run cloud services and you have felt the pain of grepping logs, which I have because I'm a hardware engineer, but I still run cloud services. If you felt the pain of grepping logs, then you should talk to Lightstep. So those are our phenomenal sponsors. Let's have a round of applause for our phenomenal sponsors. This year we had an excellent sponsor. Twilio came in at the excellent sponsorship level. And I want to say that I actually, for one of my clients, I use Twilio. And like Their sales organization is really, really good, and their product is really, really good. So if you have cause to put a SIM card in something and program the SIM card, you should talk to Twilio. And on the other end, if you want to answer somebody's telephone call or answer somebody's SMS, then you should also talk to Twilio. So those are why you should talk to Twilio. Let's give them a round of applause. We came in with 4 awesome sponsors this year. Recurse Center, we love Recurse Center. Okay, Recurse Center, if you want to go take a break from your job and spend 6 weeks learning to do something self-directed, if you want Bang Bang Con for 6 weeks, you should go talk to Recurse Center. So Recurse Center are great. And by the way, they sponsored, if you're watching on the live stream or if you're watching a recorded version of this, Recurse Center sponsored that. We had Mapbox. So they do, as the name might suggest, they do custom integrated maps. And if you use Strava, which I do, I'm kind of like a cyclist nerd, all of their new map tiles and special maps that have elevation and all that kind of stuff, that's Mapbox. Another sponsor is Accelerated Tech, which is this weird 2-person consultancy. That's me. Building hardware and software solutions, and also come work with me. So like if you really like that kind of thing, hi, come talk to me. Heap, so they're doing web product analytics. So if you want to know where people are clicking on your website and why they are or are not converting to click the buy button on your website, you should talk to Heap Analytics. So those are our 4 awesome sponsors. Can I have a round of applause for them? Okay, I have a supporting team. From UCSC, we had Adi Weinstein and Melissa Baker who helped us actually order the food, which is good. Juan Perez and Phil Johnston from Learning Technologies helped us. And in particular, I want to thank Juan, who came in here at 8 a.m. Saturday morning to help us get all of that set up. I think that's super incredible. And the university catering team, they were responsible for the snacks and breakfasts and coffee. And the grounds and custodial staff, who are supervised by Eva Banuelos. The transportation staff for shuttle buses. I don't know if you took the shuttle buses this year. If you did, I can't express my gratitude enough for them getting all that set up. In the back there, Cindy Backman and Demi Smith have been recording all of the slides and have done all of this effort to get the live stream up and running there. The Confreaks team and white coat captioning, Mirabai Knight is over on that screen typing right now. Can I have a round of applause for all of the above? I have a bunch of speakers. So there are too many speakers. I cannot list the name of every speaker. I do want to give shout outs especially to Kate Compton. We had 3 speakers who bailed at the last moment. Literally Thursday night, we had 2 speakers who had a health emergency, another speaker who had another personal emergency. And so Kate came in here and gave this incredible keynote on 2 days of notice. And I just can't express my gratitude enough for Kate Compton and all of our speakers. And finally, so I think that's all that I have. The organizers for this weekend, Dima Abu Adas, Dev Purandari, Gargi Sharma is somewhere in the back there, along with Gina Lee, Lindsay Cooper, Varun Gandhi, and I am Joshua Wise. The shuttle is at 4:40 p.m. Thank you very much. Good night. Get home safe.